All right, my friends, that's pretty much it. We've set up everything we need to set up for Kubernetes, at least in our development local environment. We're now going to start thinking about how we can take this application and deploy it off to a production environment instead, such as AWS or Google Cloud. Now, before I show you a diagram that's going to walk through the series of steps that we're going to use to deploy this, just one quick last thing. Again, if you're seeing the not secure message up here, totally fine in a development environment. We're going to eventually fix this in the production environment. But again, in development, no issue whatsoever. Okay, so let's walk through our deployment steps. So the first thing we're going to do is create a GitHub repository. We're going to create a GitHub repo. We'll also create a Git repo locally on our local machine, and then push all of our code up to GitHub. After that, we're going to set up a Travis CI project to tie in with our GitHub repo as well. So we're going to use a very similar Travis CI focused deployment method as we did previously on both of our Elastic Beanstalk projects. Travis CI is going to be in charge of building our images and pushing them off to Docker Hub. And then after that, we're going to use Travis CI to also deploy our application to a Kubernetes cluster. You can use other CI environments if you choose to. In general, maybe not in this course, I recommend you do use Travis along with me, but in general you could use other deployment or other CI environments such as Circle CI if you choose to. They work just as well as Travis. Just in this course I chose to use Travis because in general it's a very reliable service, which makes it quite appropriate for a course. After that, we're going to set up a Google Cloud project. So again, we're not going to deploy this Kubernetes application to AWS. We're going to be using Google Cloud instead. And I've got a whole slide that I'm going to show you in this video in like 1 or 2 minutes that's going to outline the reasons that we're swapping from AWS over to Google Cloud. Again, trust me, very good reasons that we're going to use Google Cloud here as opposed to AWS. Now, something that's very important, and this is really the main point of this entire lecture, is that in order to deploy this application off to Google Cloud, you will need to enable billing on a Google Cloud account. And that means that you need a credit card or some type of payment card that is accepted by Google Cloud. Now, if you are in some country that does not have access to Google Cloud, unfortunately, you're probably not going to be able to walk through these deployment steps, but that is just kind of the reality of the situation. Now, the billing aspect here is rather important to mention this time around because unlike the Elastic Beanstalk stuff where we paid $0 if you were in the free tier or you paid very little if you were outside the free tier, unfortunately this Kubernetes project is going to incur just a little bit of billing and it probably is going to be for the most part unavoidable. Now, I want to very quickly show you a calculator that you can use to get an idea of how much you're going to be paying for this Kubernetes project that we're going to set up. Just so you know, I put like all the Travis CI setup stuff up here, even though it kind of makes sense to create the Google project first. I put all the Travis CI stuff earlier up here just to minimize the amount of time that we have to have this Kubernetes cluster up and running and causing you to have to pay money. So I am very much conscious of the fact that you probably don't want to be paying a lot of money to learn all this stuff. Now, if you want to get a good idea on how much you're going to be paying, you can do a Google search for Google Cloud Cost Calculator, like so. You'll find the first result here, which is products/calculator. And then on this page, we can very quickly get an idea of exactly how much money you might be paying over a short period of time that you might be running this application. So on this page, and I'm going to zoom in a little bit here just to make sure it's very legible, you can select Kubernetes engine at the top. And then under Kubernetes engine, we're going to be running 3 separate nodes. We're going to be using the standard instance type, so you can leave that as the same. So I'm going to scroll down, leave everything else the same, and I'm going to click Add to Estimate. I will then find the persistent disk section. On here, we're going to have one persistent disk that's going to have like 2 gigabytes of space. 2, like so. So you can add in a 2 and then click Add to Estimate. And then you can also find load balancing right here. We're going to have one forwarding rule, and we're going to, at best, be transferring about 1 gigabyte. Like absolute no way we're going to actually be doing 1 gigabyte here. I guess you could go down to megabyte if you want to, and we could probably say like something like 100 megabytes is probably much more realistic. And then you can add that as an estimate as well. So if you look at the total price for all this thing, it comes out to around $42 per month. Now, if you're running this for only 1 day, because the billing here is like on a per minute basis or something like that. So if you go through all the Kubernetes videos in this course in like 1 day, then you're going to be paying about $42 divided by 30. So that's something like, I don't know, $1.40 or something like that total. So $1.40 if you get through everything in here in 24 hours. If you get through it faster and shut everything down, you'll be paying even less. So in general, probably not going to be paying anywhere near $42 as long as you complete all this content in a reasonable amount of time. I just want you to be aware that you are going to be paying at least some tiny amount of money here. And you do really need to make sure that you absolutely clean up all these instances after you get through this content, especially if you like quit halfway through. You need to be making sure that you close everything down. And of course, at the end of the Kubernetes section, I'll give you a very detailed video on how you clean all this stuff up as well. Okay, so that's my spiel on pricing. Now, we're going a little bit long here, so let's take a quick pause. And when we come back to the next section, we're going to talk a little bit about why we're making use of Google Cloud over AWS. So quick pause, and we'll cover that in the next section. In the last section, we started talking about how we're going to take our Kubernetes cluster and eventually move it over to a production environment. We just spoke about some aspects of billing. I now want to give you just a quick couple notes on why we are making use of Google Cloud for deploying this Kubernetes application as opposed to AWS. Because after all, we did make use of AWS earlier on in this course, so it's a little bit strange to swap providers out halfway through in the context of a course. But again, we're doing this for a very good reason, so let me lay out a couple of reasons why we are swapping over to Google Cloud. All right, so here's my very quick checklist here. Now, before I talk about any of these points, I want you to just understand that these are my subjective opinions on why you might want to use Google Cloud for Kubernetes over AWS right now. These are entirely subjective, so people are completely free to disagree with me. No problem there. I don't mind if you disagree one bit. Totally fine if you do. So we're going to be making use of Google Cloud over AWS for these couple of reasons right here. First reason, Google created Kubernetes. They created the open source project and they supported the project financially for the first couple of years of its existence. That means to me that Google as an organization has a lot of experience with Kubernetes and they understand at a very low level why it works and what its purpose is. And so even though the people who created Kubernetes are probably not the same people who set up Kubernetes or all the infrastructure for it on Google Cloud, there's still a very good reason there to believe that there was at least a little bit of knowledge transfer. So essentially the people who set up Kubernetes on Google Cloud probably had access to some people with very low level knowledge of Kubernetes, and they probably understand very well how it works. Again, totally subjective. I could be totally wrong, but that's going to be kind of like, it's just my opinion. Now, the rest of the reasons on here are a little bit more objective than that one. So the next one, AWS only somewhat recently got Kubernetes support. That's in early 2018. Now, you might be watching this video in 2019, 2020, or even later, and maybe at some point in time, AWS will catch up with Google Cloud's implementation, but as it stands right now, the UI and the interface for manipulating Kubernetes clusters on AWS leaves a little bit to be wanted. Like, it's not that great, it's not that easy to use right now. So using Kubernetes from a UI perspective on Google Cloud, far easier, much easier, far easier to get started with because they've had a number of years to iterate on this product ahead of AWS. Next up, it is far easier to kind of mess around with Kubernetes far easier to mess around with Kubernetes on Google Cloud than it is on AWS. So in Google Cloud, we get something called a Cloud Console, which is essentially a terminal instance connected directly to your entire VPC of sorts hosted on Google Cloud. And so you get direct access to a kubectl command line tool that's wired up to your production Kubernetes instance. And we'll actually take a look at that in just a little bit. And so using this tool, you can very easily run all the same exact commands, like say kubectl get pods. You can run all these same commands in a production environment that we've been running locally. And on Google Cloud, that is extremely easy to set up and very easy to do. Now you can certainly set up the same system on AWS, but it's far more involved, much more involved. Really easy to get started just poking around with things on Google Cloud than it is on AWS. And then finally, in my opinion, again, these are some subjective elements here. In my opinion, the documentation around Kubernetes on Google Cloud is like light years ahead of the AWS documentation. Take my word for it. To a certain degree here, I am in the business of teaching people that stuff. I'm teaching you right now how to make use of Docker in Kubernetes. To a degree, I like to imagine that I've got a good understanding of what documentation is. And in my opinion, the Google Cloud documentation is just head and shoulders above the AWS documentation for Kubernetes right now. So take that for what you will. All right, so that's it. That's the 4 reasons that we're making use of Google Cloud for this stuff. I just wanted to be very clear about these reasons. I wouldn't normally kind of list these out or iterate them out, except in this case, we made use of AWS earlier in the course. And so again, it is kind of strange to swap off to another cloud provider halfway through. But again, I really think that there is very good reason to do this swap off. Much easier to get started with Kubernetes on Google Cloud. All right, so enough of this. Let's take a quick pause right here, and we're going to get started in our next section with our production deployment by setting up a GitHub repository and pushing our code up to it. So quick pause, and I'll see you in just a minute. All right, my friends, in this section, we're going to start the long process of getting our Kubernetes cluster over to a production environment. So step number 1 is to create a new GitHub repository that's going to eventually house all of our source code. Now, we have already made a GitHub repository for our project in the past. I'm going to create a totally separate repository so that there's no confusion between this Kubernetes stuff and all of the Elastic Beanstalk stuff that we had done previously. So I'm going to first navigate to GitHub. And then once here, I'll find the little plus on the top right-hand side, and I'll make a new repository. Now I'm going to call this repository multi-K8s, like so. You can call it anything else you might want to call it, totally up to you. I'm just going to choose the name multi-K8s. I'm then going to make sure that the repository is marked as public, and then I'll click on Create Repository. Okay, great. So there's my link right there. I'm going to copy the link, and we'll now create a local Git repo and set the remote to be this GitHub repository. So I'm going to flip over to my terminal. Now, quick reminder, you have already created a Git repo inside of the complex directory earlier in this project, and you had used it to deploy the multi-container application to Elastic Beanstalk. So I want you to do a ls-a right now. And if you see inside of here a .git folder, that means that you've already set up a local Git repository, and you do not need to create a new one. Now, I do not have a Git repo inside this folder, so I'm going to now create one with git init, and then I'll do a git add and a commit. Like so. So now I have a Git repository inside of here as well. I see the .git folder. Now again, if you already had a .git folder inside of here, you probably already had a remote set up for the previous GitHub repository that we had created. So I want you to do a git remote -v right now, like so. If you run that command and you see something come up that says like origin and the name of a repository next to it, then you're going to want to delete that remote and change it over to be the new GitHub repository that we just created. So to delete the existing remote, you can run git remote, remove origin. There we go. That's totally off the top of my head here. So you can run that command and it will delete the existing remote called origin. Then to wire it up to our new GitHub repository that we just created, we'll run git remote add origin, and then I'll paste in the link that I just got off of the GitHub page over here. So this link right here. So I'll paste that in, and there we go. So now I can do a git remote -v, and I'll see the origin appear with the new repository name. Now I'm going to do a push to send all the code that we just added inside this repo up to GitHub. So I'll do a git push origin master, like so. Now after a second or two, we'll see a little message here that says the push is complete. So I'm just going to wait for that. Okay, there we go. Push is complete. So now the last thing I want to do is flip back over to GitHub. I want to refresh the page, and I want to make sure that I see all of my work inside this directory here. Now you'll notice I got that stupid, I hate this file, ds store. It's from when you copy paste stuff around on OS X. I'm going to take care of that in just a second. But you should see at least the client, server, worker directories, along with the K8s folder as well, with all of our different config files inside there. So at this point, please make sure that you have those 3 different directories along with the K8s folder as well. If you don't have this, then you need to do a little bit of work on your Git repo. All right, so let's take a quick pause right here, and we'll continue in the next section. Our next step is going to be to wire up this GitHub repository to Travis CI. So I'll see you in just a moment. In the last section, we created our GitHub repository, and we linked it up to a new local repo. So we should now have everything up on GitHub, as you see right here. The next thing we have to do is take that repo and tell Travis CI that it needs to watch that repository and watch for us pushing code to it. So to do so, I'm going to open up a new browser tab, and I'll navigate to travis-ci.org. Now, once here, remember we have to refresh our list of Git repositories. So up on the top right-hand side, I'll click on Profile, and then on the left-hand side, I'll find the button that says Sync Account. So I'm going to do a manual sync. Now, this might take a second or so for it to complete. Okay, I'm kind of lucky this time around. It usually takes a little bit longer than that. So now I'm going to refresh this entire page to refresh the list of repositories right here. And then I'm going to do a search for the repository that I just created, which was multi-K8s, like so. So there's the repo I just made. I'll click the little slider over here to enable it for building. Cool, so that's pretty much it. We can now go back over to the Travis CI dashboard by using the link at the top left-hand side, and we'll see multi-K8s as a new project inside of here. So now the next time that we build code, this thing should start up and start running and hopefully run whatever Travis YAML script file that we put inside there. So let's take a quick pause right now. When we come back to the next section, we're going to start to create our Google project, and we'll also start to put together our travis.yaml file. So quick pause, and I'll see you in just a moment. We've now got our GitHub repository created, and we've linked it to Travis CI. We're now going to start to work on our Google Cloud project using the Google Cloud Console. We don't forget that we do have to eventually go back and create a travis.yaml file telling Travis how to eventually process our code and build our images and deploy our application. But in order to do that, we actually need a little bit of information that has to come out of our Google Cloud project. So unfortunately, we got to create the project first and then go back over to Travis. So to create a new Google Cloud project, we're going to navigate to the Google Cloud Console at console.cloud.google.com. I'm going to open up a new browser tab right now, and I'll navigate there. So console.cloud.google.com. Once you come here, you're probably going to see some project immediately on the page if you've ever signed up to Google Cloud before, or you might see a listing of projects like so. If you've never created a Google project before, or a Google Cloud project, then you'll probably see some type of like startup screen or a startup wizard of sorts. No matter where you end up at, we want to create a new project. You could find the new project selector by opening up this project menu using this little drop down on the top left-hand side, and you can click on the new project button on the top right. Once here, we are prompted for a project name. And so I'm going to use a name of something like multi-K8s, like so. I'll then click on create, and then you'll be dumped back over to whatever page you were just looking at. So if you are looking at a dashboard right now, notice that it's probably not the project you just created. It actually takes a little bit of time for your project to be created, and you can watch the status of it using the spinner on the top right-hand side. So I'm just going to pause the video right here, and I'm going to wait for the project to be created. Now it looks like the project was just finished, but nonetheless I am going to pause the video anyways, just in case yours is taking a little bit longer, and I'll see you in the next section. So, in the last section, we created a new Google Cloud project. After the project is successfully created, and you'll see a little notification for it up here on the top right-hand side, we need to make sure that we select that new project as our active project. So to do so, I'll find the project dropdown right here, and then I'll find the multi-K8s project that I just created. So I'll click on that, and then I'll very quickly see my dashboard for the newly created project up here on the screen. Any second now. There we go. So at this point, double check on your project name over here on the left-hand side and make sure it has the project name that you just entered. All right, so now that we've created our project, we do have to enable billing for the project as well. So in order to do all this Kubernetes stuff, you absolutely have to have a credit card associated with your Google account. In order to enable billing, I'm going to go up to the navigation menu on the top left-hand side, and then I'll find the billing selection right here. Now, once I go to billing, I'll see that I have not set up billing or linked it to this project. Now, just so you know, if you do not see this window right here, and if you instead see some like billing information appear on the screen, that's totally fine. It very likely means that you've already set up a billing account in the past, and it automatically got linked to the project that you just created. So if you do not see this window, you're probably A-OK and just fine to go. You can pause the video right here and continue in the next section. Otherwise, we have to link a billing account. So I'm going to click on the blue button right here. And then I get prompted because I already have a single billing account set up to link my project to it. So I'm going to click Set Account right here. But for you, you're going to see a wizard that will walk you through the process of creating a new billing account. It's going to eventually ask you to enter in some payment details and give the billing account a name. After you do that, you can then come back to the billing page and link this billing account to the project that we just created. Okay, so eventually we should see a screen like this right here, something that lists a billing account, like a billing account ID, and it should list your project as being linked to this billing account. So now that we've set up billing successfully, we're going to take a pause right here and continue in the next section with some of the Kubernetes setup. In the last section, we finished setting up our new account and we linked a billing account to it. We now have to attempt to create a new Kubernetes cluster. So to do so, I'm going to go up to the navigation menu up here at the top left-hand side, and I'm going to scroll down to the compute section. Inside of the compute section is Kubernetes Engine right here. So I'm going to click on Kubernetes Engine, and then eventually it will resolve to a little window like this. Now you might notice that you still have this enable billing window right here. If you do, you can probably just refresh your browser. If you still see it after that, you might have to go through the billing process again and just make sure that you set up everything correctly. So me personally, I'm just going to refresh my browser, and I should see that message go away. Okay, so that's much better. So I now see instead a message that says Kubernetes Engine is getting ready. So unfortunately, when you first create your account and access the Kubernetes Engine page for the first time, it has to do some one-time initial setup to get your account ready for creating a Kubernetes cluster. So again, we're going to take a quick pause and let this thing finish up. Now before we pause, just so you know, you'll see that there's two spinners on the screen. There's one spinner right here and one spinner on the top right hand as well. The spinner down here is going to stay around forever, probably. At least in my experience, it never actually goes away. And it's only the spinner up here on the top right hand side that's going to eventually resolve. So if you see the spinner up on the notification bar go away, but this one is still running, try refreshing the page and chances are the getting ready message right here will go away. So in other words, just try refreshing the page every now and then. If you do refresh the page, it does not interfere with the setup process at all. So feel free to refresh as you please. All right, so let's take a quick pause and we'll catch up in the next section when everything is ready to go. In the last section, we started to initialize our Kubernetes engine. Now you'll notice that up here on the top right-hand side, it looks like the spinner has stabilized, but I still see the one on the screen right here. So I'm just going to refresh the page very quickly. And then when I load back in, you'll notice that that spinner up there totally gone. So it looks like everything was ready to go anyways. So now that Kubernetes cluster is warmed up on my account, we can now create a new cluster. I'm going to click the Create Cluster button right here. And then that's going to present us with a little wizard to go through to create our new cluster. A lot of the information we have to enter here is going to be somewhat obvious, but some of it might be a little bit more esoteric. So let's walk through this thing step by step. The first thing we have to provide is a cluster name. Now the name you provide here, totally up to you. We're not going to really be using the name in many places. Me personally, I'll use a name of K8s, actually about multi-cluster. That's better, like so. We're going to leave the location type as zonal, and then we get asked to select a zone. I recommend that you select a zone close to wherever you are trying to serve traffic to, or alternatively, just a zone that is close to your geographic location. So for me, I'm going to leave it on my default selection of US Central 1A. I'll then leave the master version as the default setting, and then we get asked to create something called a node pool. So the node configuration right here is describing the specifications of each different virtual machine that will be added to your Kubernetes cluster as a node. Remember that inside of our local development environment where we use Minikube, we only had one single node. But now that we're moving over to production, we can dramatically increase the number of nodes that we are going to get access to. The default is 3, but we could very easily change this to 1 or 10 or even 100 if you have some application that demands that much computing power. For us, a number of 3 is totally appropriate, totally fine. After that, we get prompted to select a machine type. The machine type is really saying how or what specifications we want these virtual machines to have. The default selection is one virtual CPU with 3.75 gigabytes of virtual memory. You can also select micro and small right here and save a couple bucks. Now, I want you to know that when I was initially developing this application and deployed it to Google Cloud, I tried using a small instance, like this small instance right here, and I eventually ran into a couple of issues. Now, to be honest, I don't know if that was an issue I ran into because of some other unrelated setting, because I was doing a lot of iteration at the time, or if it was because the small instance did not have enough memory. Now, my gut tells me that 1.7 gigabytes of memory is definitely enough for what we're doing, but I don't know. If you want to just guarantee that everything is going to work the first time around, go with the default option of 1 vCPU with a 3.75 gigabytes of memory. Now, do remember that we're going to get 3 of those machines. So in total, we get 3 virtual CPUs and 3 times 3.75 gigabytes of memory, which is something like, I don't know, what is that, 11.25 gigabytes total, or something like that. I could be wrong. Now, we don't need to make use of any other advanced options on here. So the last thing we'll do is click Create. Now, I want you to understand, remember, we are paying money for these instances. You will be billed. The free tier is probably not going to cover this to any significant degree. So at the instant you click Create right here, billing kicks in. So at this point, if you feel like you're going to take a big break before completing the course, maybe don't click Create just yet. Just make sure that as soon as you click Create, you have enough time to finish up the course in a reasonable period of time. Remember, by my estimate, you might be paying like $1.20 or something like that, $1.40 per day that this cluster is running. So just make sure that you kind of wrap everything up in a reasonable amount of time. All right, so I'm going to click Create, and that's going to start creating our cluster. Now, this entire process of setup is going to take just about as long as all the other waits we had. So I'm just going to sit here and wait for a bit and let this thing do its little bit. Now, again, remember that the spinner down here might not resolve by the time that it's actually set up. So the spinner you really want to be watching is the notifications up here. As soon as this thing is solid, if it's still spinning down here on the body of the page, just try refreshing your browser and chances are this will get resolved as well. Again, remember that if you refresh the page, no issue whatsoever. You can refresh as much as you want and it will not interfere with the setup process. So feel to refresh willy-nilly, totally up to you. All right, so we'll take a pause right here. When we come back to the next section, we're going to start poking around the cluster that gets created for us. So quick pause and I'll see you in just a minute. In the last section, we created our first Kubernetes cluster on Google Cloud. In this section, I want to very quickly walk through this dashboard and show you a couple of interesting pieces, some different things that are going to be relevant later on as we start to actually deploy our application. The first thing I want to do is click on the multi-cluster right here that we just created. On this panel, you'll see some information about the configuration of our cluster. Now, it's not super common for you to have to come in here and reference information, but you will see some interesting stuff in here that you might need to make use of at some point in time in the future. Towards the bottom of this page, you're going to see information about the different nodes that are in use in our cluster. And so if you ever need to change the specs on the different nodes here, for example, add memory or add a more powerful CPU, you can do it from this interface here. Now, besides showing information about the cluster, you'll also notice that there's a couple of different tabs on the left-hand side. We can check out workloads right here. This is going to be a page that's going to eventually show all the different pods and deployments that belong to our application. At present, we have nothing running on our cluster, so this window is completely empty. We then have the Services tab. As you might guess, this is all about different services that we create inside of our cluster, like the cluster IP service, or a load balancer if we create one, or the node port services, all that kind of stuff. You're all going to see eventually show up on the Services tab. Now, Applications right here is really talking about different kind of plugins that we can install and make use of inside of our cluster. So this is not talking about different pods or deployments that we're running. This is talking about some third-party software that might run inside of our cluster. We're not going to be making use of any third-party stuff, so we are going to generally ignore the Applications tab. The configuration is going to show all the different environment variables or secrets that we set up inside of our cluster. You'll recall that we have one secret in use right now, which stores our Postgres password. And so eventually we're going to see that secret appear on this configuration tab. Then finally, storage is going to list all of the different persistent volumes and persistent volumes claims that are set up inside of our cluster. One quick thing I want to remind you about, let me see if I have the diagram up for it. Here it is right here. All right, this is a diagram that we looked at a long time ago when we were talking about persistent volumes and persistent volume claims. You'll recall that we had said that on your local computer, we had a default provider for storage. And on your computer, Kubernetes said, okay, I'm going to take a slice of your hard drive and dedicate it to a persistent volume. That was what was happening on your computer. Remember, the entire point of that discussion was to say that the environment that Kubernetes is running in is going to assign different default classes of storage. And so we'd also said that on a cloud provider, if we tell Kubernetes that we need 1 gigabyte of storage, then Kubernetes is going to try to select from one of these different services that is provided by our cloud provider. So in the case of Google Cloud, our default storage provider is called Google Cloud Persistent Disk. And in fact, if you go back over here to the storage tab and then look at storage classes, you'll see that we have one storage class called standard. This is our default. And if I click into it, you'll see somewhere around here, maybe not on this page so much, but definitely back on this page, you'll notice that it says GCE-PD right there. So PD stands for persistent disk. And if we Google that right now, Google Cloud Persistent Disk, yep, this is the offering from Google Cloud to reliably store some information consistently and not have it be kind of wiped away magically at some point in time. So, as we had said before, because we are now in Google Cloud, some of these default options that Kubernetes is going to use are going to be slightly different than what the defaults are on your local machine. And looking at the persistent storage is a great place to kind of get an idea of the fact that, yeah, now that we're in the cloud, things are a little bit different. Okay, so that's pretty much it for Kubernetes engine, this dashboard right here. Now we are going to come back to this dashboard several times and do a couple different things. But for right now, we're going to start to focus on adding a deployment script to our repo. That's going to be our travis.yaml file. We're going to make sure that everything is set up to automatically deploy our application off to this Kubernetes cluster as soon as we push and merge our code on the master branch of our GitHub repo. So quick pause, and we're going to start that in the next section. In this section, we're going to start talking about the travis.yaml file that we're going to put together to build all of our different images and then eventually deploy our application to our Kubernetes cluster. Now, unfortunately, all the travis.yaml files we put together before were all kind of preparation for the one that we're going to put together now, because by a large margin, this is going to be the most complicated travis.yaml file that we're going to put together. A lot of stuff is going to be going on inside of here, a lot of different configuration. So I've got a little flow diagram to give us an idea of what we're going to be doing inside of our config file to eventually deploy our application. So everything is going to start inside of our config file by installing a Google Cloud SDK. Remember, the entire purpose of Travis, as we are using it, is to not only test our code, but then to also deploy our application after our test runs successfully. And so we need to make sure that Travis has the ability to somehow reach out to our Kubernetes cluster and make changes to it, or essentially run a series of configuration files and apply them to our cluster. So to do so, we're going to install a Google Cloud SDK. This is a CLI that is going to allow us to essentially remotely interact with and configure our Kubernetes cluster, most notably by applying different config files. Now, unfortunately, this SDK does not come kind of pre-configured with Travis. In other words, we have to actually download and install the SDK every time that we run our Travis build. So after we install this thing, after we download and install it, we then have to configure the SDK with some information from our Google Cloud account. Essentially, we're going to authorize this CLI to make changes to our Google Cloud account, and more specifically, the Kubernetes cluster that we just created. So that's kind of a little bit of preamble, some stuff that we're going to do at the very start of the script and get this CLI ready to then later on deploy our application towards the end of the process. After that, we're then going to start to go through some steps that are very similar to what we had done previously on our other different Travis builds. So we're going to log into the Docker CLI. We're going to build the test version of the multi-client image, and we're going to use that thing to run our tests. Remember, we don't really care about the tests that are inside of that multi-client image. I just want you to have a good example of how you would run some tests inside of your application, so that when you actually go and apply all this knowledge to your own personal project, you understand like, okay, at this phase right here, I'm going to run a command that's going to execute my tests. Again, we don't really care about the tests in our particular case. After that, if all the tests run successfully, we're going to run a script. So this will be a separate script outside of our travis.yaml file that's going to attempt to deploy the newest images. Inside that script, we're going to build all of our different images. So that's the multi-client, multi-server, and multi-worker. And then we're going to push each one off to Docker Hub. After that, we're then going to apply all the different config files inside of our K8s directory. So specifically, everything inside of here, we're just going to apply the entire directory. Now, the benefit to that is that if at some point in time you and I decide, oh, hey, we need a new deployment or we need a new service or whatever it might be, all we have to do is add a new file to the K8s directory and then push our code up to GitHub. After Travis builds our code, it's then going to apply all the config files in that K8s folder. And so essentially, our Kubernetes cluster is always going to be 100% in sync with our GitHub repository. Any changes that we make to our config files in the K8s directory are always going to be applied to our Kubernetes cluster in Google Cloud as soon as we push our code off to Travis. So overall, it's actually a pretty cool system. Now, after we apply those configs, we have to do one other little step. Remember, we had a lecture a while ago where I showed you how it was kind of a pain in the rear to get a deployment to use the latest version of an image. We saw that if we just tried to reapply a deployment config file, that did not somehow magically get the deployment to automatically go out to Docker Hub and check to see if a new version was available. And so as a workaround, I had showed you that very special command that very imperatively set the image version that a deployment was supposed to use. And that's how we're going to eventually get our deployments to make use of the new images that we built during this step right here. So in addition to applying all those configs, we're also going to make sure that we do some imperative command to update the versions of each image that each of our deployments is making use of. Okay, so a lot of knowledge here. Like I said, this is going to be a really intense travis.yaml file, and there's even a couple steps during this process that I didn't actually write into this diagram just because it would make the diagram a little bit crazy. So a lot of stuff going on, a lot of stuff to talk about. So let's take a pause right here. In the next section, we're going to create our config file and start by installing the Google Cloud SDK. So quick pause, and I'll see you in just a minute. All right, my friends, in this section, we're going to start working on our Travis config file. So without any further delaying on my part, let's flip over to our code editor. Inside of my root project directory, I'm going to make a new travis.yaml file. Now, I want you to remember we have a leading period in the name of this file. So I'm going to put in .travis.yaml, like so. Or we can just do the abbreviation YML, same thing. So .travis.yml. So now inside of here, we're going to eventually end up with a tremendous amount of configuration. Some of the stuff inside of here is going to look rather familiar, and a lot of it is going to be pretty new. So we're going to kind of speed through the stuff that we already understand and get over to some of the new stuff. So the first thing I'm going to do is add on sudo required because we're making use of Docker. I'm then going to say that we require the Docker service to be pre-installed as soon as we try to run our build, because we definitely need Travis to build our images and even run that test container. After that, we're then going to add on a before install flag. So this is going to be a series of steps that's going to essentially do just about everything up to that point. These first 4 things right here. Now, the first thing that we're going to do is attempt to download and install the Google Cloud SDK. So to do so, kind of hard for me to give you a good explanation of where this command is coming from. Essentially, this is something that you would go and do a little bit of research on and just read up on how to install the Google Cloud SDK. Of course, I'm going to show you right now. I just want you to understand that this is kind of, something coming from the outside world. So we're going to do a curl https://sdk cloud google.com. And then we'll put a pipe, so that's a vertical symbol right there. It's shift and then the key above your return button. That is not an L. So not an L, not a capital L, not a capital I, it's a pipe symbol. And then we'll say bash /dev/null and then a colon, like so. All right, so this command right here is going to download the Google Cloud SDK, and then everything on the other side of the little pipe right here is going to install it locally on our little instance that is assigned to us by Travis CLI. After installing it, we're then going to run one other kind of strange command. I'm going to say source $home Google Cloud SDK, and then path.bash.inc. So this right here is going to look at the default install directory of Google Cloud SDK, which is, again, by default at home Google Cloud SDK, and it's going to source the file path.bash.inc. Essentially, that just means that there's some configuration that's going to modify our shell inside of Travis CI inside this file, and we're going to apply that additional configuration through the source command. Again, these two lines of configuration right here, kind of something that you would look up ahead of time and just be told, hey, run these two commands, and it's going to set up Google Cloud locally on your machine for you. Okay, so then after we install this thing, we're going to make sure that Google Cloud, or the CLI, is going to also install the kubectl command, the same one that you and I have been using throughout this course to manipulate our Kubernetes cluster. To do so, I'll write out gcloud components update kubectl, like so. So that's going to install and update kubectl inside of our Travis environment. And again, we're going to eventually use this kubectl to apply all those different configuration files and some of the other imperative commands we have to run to set our images on each deployment. Now, after doing all this initial setup, we then have to do some authorization with Google Cloud, or this gcloud SDK. We have to tell it, hey, this is who we are, and here's our password, or whatever it might be, everything that it needs to actually log in and get access to our account. Now, the command for this is going to be a little bit more involved. We're going to write out the command, and then we'll talk about exactly what it's doing. So I'm going to say gcloud auth activate service account -- key file, and then service account.json, like so. All right, so you might remember back when we were working with AWS and Elastic Beanstalk, we had created that IAM user, and we had assigned it some number of permissions that essentially allowed that kind of user that we made use of inside of Travis CI to actually access our copy of Elastic Beanstalk and do a deployment at some point. This service account right here, the activate service account, is essentially equivalent to that entire IAM system. So in order to tell Google Cloud, or this SDK, who we are and give it access to our account, we have to activate a service account and then provide a set of credentials inside of a file that we are calling serviceaccount.json. So inside of this file that does not exist yet, we haven't created it, we're going to eventually need to put some information that's going to give clear access to our Google Cloud account. Now, as you might guess, these credentials that are going to be placed inside that file are extremely sensitive, and in no way, shape, or form would we ever want to allow anyone to get access to those credentials. So let's take a quick pause right now. When we come back to the next section, we're going to generate this set of credentials that are going to allow access to be given to our account, and then we're going to make sure that we somehow securely add them into Travis. So quick pause, and I'll see you in just a minute. In the last section, we started working on our travis.yaml file. We've now got some configuration that's going to install the Google Cloud SDK. It then is going to download and install the kubectl command line tool. And then finally, we had said that we need to make sure that we essentially authorize the Google Cloud SDK with some service account. And the credentials for that are going to be placed inside of this serviceaccount.json file. Now in this section, we're going to create the serviceaccount.json file. We're going to put some credentials in there, and then we're going to somehow hook it up to our Travis CI build. Now here's the entire series of steps that we're going to go through. So the first thing we have to do is log on to our Google Cloud console, and we're going to create a service account. Remember, a service account is very similar to that IAM user that we had created back on AWS. It's essentially a set of credentials that's going to allow programmatic access to our Google Cloud account. When we make that service account, we'll then be provided with a JSON file that contains the account credentials to access the service account. So that JSON file is a very sensitive little file, and we really want to make sure that the information inside of it does not get exposed to the outside world. So to make sure that we don't have to commit that file to GitHub and accidentally push it up to GitHub or anything like that, we're going to encrypt the file and store the encrypted file on Travis CI's servers. Now we've already gone through an example where we made use of an environment variable that was encrypted with Travis CI, but that was with a string or just a simple environment variable. This time around, we want to load up a file that gets encrypted and stored with Travis, as opposed to a simple string. So to do so, we're going to download and install the Travis CLI. Now, the real name for this would be like the Travis CI CLI, but I realized that was kind of confusing. So we're going to download Travis CLI on our local machine, and we'll be able to use that CLI to encrypt this file and store it with Travis. So we're going to encrypt it, and then upload the JSON file and tie it to our Travis account so that it cannot be viewed as plain text by anyone else in the world. Then finally, inside of our travis.yaml file, we're going to add a little bit of configuration to take that file that we just encrypted and uploaded. We're going to unencrypt it, unencrypt the JSON file, and then we're going to take the JSON file and load it into Google Cloud, or the G Cloud SDK. And this is essentially the line right here that's going to do that. This line is what takes that JSON file and loads it up and tells the Google Cloud SDK that, hey, here's who we are, and here are the credentials that you need to access our Kubernetes cluster. Okay, so let's get to it. Step 1, create a service account. So I'm going to go back over to my Google Cloud dashboard. On the top left-hand side, I'll find my navigation menu, and then I'm going to scroll down to IAM and admin right here. Now on this page, you might already see a bunch of different things created here. I don't recall if these are, these are brand new. I'm pretty sure these are brand new. I was going to say I can't recall if these are automatically generated or what, but I'm pretty sure these will automatically generated. Now on the left-hand side, I'm going to find service accounts. Then on the top right-hand side, I'll say, oops, not that one. Let me zoom out here. I can't actually see everything because I'm running a little zoomed in. There it is, create service account right in the middle. Okay, so we're going to put in some information to this thing. First, we have to provide an account name. You can put any name in here that you want. It really doesn't matter. It'd be nice if you just kind of, as the note says, kind of describe what this service account is going to be used for. So I'll call this thing, how about Travis Deployer? I think that makes enough sense. We then have to assign a role, which is essentially the permissions that this service account is going to have. So in this table, I'm going to scroll down and find Kubernetes. So here's Kubernetes engine, and we're going to make it an engine admin because this is going to be a service account that has total control over our cluster and can easily create new objects, delete objects, edit them, whatever needs to be done. So I'll click on that, and then we'll select furnish a new private key. And we want to get a JSON file for our private key. So that's pretty much it. I'm then going to save the file, or excuse me, save the new service account. And then I'll be automatically prompted with a download here for the JSON file that has our account credentials inside of it. So I can close this window. And then this JSON file right here, this is the very important thing that we want to make use of and eventually encrypt and upload to Travis CLI. Now, I want to be 100% clear, this is extremely important, so please listen very carefully. This file that was just downloaded, under no way, shape, or form do I ever want to accidentally expose this JSON file to the outside world. So I'm going to make 100% sure that I do not accidentally commit this file to Git or upload it to GitHub or anything like that. So again, please make sure that you treat this file very carefully and do not accidentally expose it to the outside world. All right, so now that we've created our service account, let's take a quick pause right here. When we come back in the next section, we're going to download and install the Travis CLI. So quick pause, and I'll see you in just a minute. In the last section, we created our service account, and we downloaded a JSON file that contains some credentials for that service account. We now need to download and install the Travis CLI, which is a program that we're going to use to encrypt that service account JSON file and tie it to our Travis CLI account. Remember, the entire idea behind this is that the JSON file we just downloaded, so this one right here, has some very sensitive information inside of it, and we do not want to expose it to the outside world from our GitHub account. All right, so to download and install the Travis CLI, we can go to github.com, blah, 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 and download this thing and install it. However, there's just one little awkward thing about the Travis CLI, and that is that it requires Ruby to be installed on your local system. Now, if you are on a Mac OS machine, you're in luck because by default, Ruby is installed on Mac OS. However, if you are on Windows, well, life is a little bit harder. On Windows, installing Ruby is a little bit more challenging, and it's kind of a pain in the rear. Now, I would hate to have to go through the Ruby installation process with you if you're on Windows because it is a little bit of a pain and it takes a decent amount of time. But there is a little workaround that we can use. I want you to remember, what have we been doing in this entire course? We've been creating Docker images and containers. And the entire purpose of these containers is that we can very easily get some different environment up and running on our local machine with some very customized dependencies inside of that container. So I think that rather than trying to install Ruby locally on your machine, especially if you are on Windows, instead, let's try getting a Docker image that has Ruby pre-installed inside of it. So we're going to get an image that has Ruby pre-installed. We'll then open up a shell or a terminal inside of that container, and then we'll use that to install and run the Travis CLI. There's only a single command we have to run with Travis CLI, essentially, just the one command to encrypt that file that we care about. So we don't really need a persistent version of the Travis CLI to sit around because we just want to use it one time and then throw it away. So this would actually be a great use case where we could use a Docker container with Ruby already installed inside of it to install Travis CLI, use it to encrypt the file, and then throw the entire container away because we don't need it for anything else. So let's give this a shot. Now in this section, as we go through this process, we are going to be running a good number of commands. And so I wanted to put all the commands up here and all the different steps we're going to go through, just in case you are skipping through this video rather quickly. I want to make sure that you don't accidentally skip one of the commands inside of here. So I would almost recommend that you take a screenshot of this diagram right here, just to make sure that you nail each and every one of these commands. So the first thing that we're going to do is execute a Docker run command. The image that we're going to be running is Ruby version 2.3. And then at the same time, we're going to start up a shell inside there, and we're also going to set up a volume. The purpose of the volume right here is to eventually get the service account JSON file inside the container. Remember, this is the file that we want to encrypt, so we need to make sure that it is available inside the container. So we're going to use a volume to do that. Now notice that we're using the $ parentheses interpolation here. This is only valid if you're on a Unix-based system or if you're on Windows using git bash as your terminal. If you're on Windows and you're using something like the command line or PowerShell, you're going to use curly braces there instead. So just be aware of that little difference. Okay, so let's get to it. I'm going to open up my terminal, and I'm going to make sure that I'm inside of my complex directory because we're going to eventually put that JSON file inside of here and encrypt it. And we're using specifically the complex directory because remember, we're going to make sure that the volume is available inside the container. All right, so we'll do docker run -it -v to set up the volume. I'll say $pwd to say present working directory of the complex folder. I'll then do a colon, and I'm going to map this present working directory of complex to the folder about app inside the container. Now we don't actually have any app thing to put inside the container. I'm just choosing that folder name totally at random. We could probably figure out a better name, but honestly, it just doesn't really matter that much. We'll then specify the image of Ruby 2.3. And then the command that I want to run inside of this container is sh to start up a shell inside there. Okay, so I'm going to run this command. Now, when I run the command, I immediately get kicked into a terminal right here, or a shell inside the container, because I've already downloaded the Ruby image in the past. For you, you probably need to download this image, and so it's going to take maybe a minute or two to download the image and then eventually create a container out of it. So I encourage you to pause the video right now and just leave it paused until you eventually get into a shell like so. Okay, so if you're now here, I'm going to assume that you've successfully gotten into a shell inside the container. So if we now do an ls, we can see that app folder. So there's the app folder right there, the one that we just set up as a volume. If I change into that app folder, and I encourage you to do so right now as well, so I'm going to make sure I'm inside that app folder, I can do an ls, and I'll see all of the project folders out of our original complex directory. Okay, so that definitely worked out pretty well so far. So now the next thing we're going to do is install Travis. This is the Travis CLI. We're installing it by using the program Gym. Gym is essentially a dependency manager for the Ruby programming language. So we're using the Gym program to install Travis. So I'll do Gym install Travis, and I'll put on no-rdoc and no-ri. And these two flags over here at the right-hand side, these are 100% optional. They're essentially just saying, do not attempt to install any documentation along with this gym. It just makes the installation go very, very slightly faster. All right, so I'm going to run this. And then we're going to very quickly see everything get installed. All right, now it looks like I paused there for a second on building native extensions. Now, something kind of interesting that I want to mention, this is a total side topic, completely unrelated from all this Travis stuff, and you're probably going to hate me for going on a side topic while we're running all these intense commands, but I have to do it. I have to tell you about this side topic. I feel 100% compelled to do so. So you'll notice during that entire process, it says building native extensions right here. That's essentially a step where Ruby and the gem program are taking a bunch of Ruby source code files and essentially compiling them to get them to work on your local system. Now that's kind of a build step, and it requires some modules inside of Ruby to be installed, or essentially these kind of development programs to be installed with Ruby. One thing you might notice that's kind of interesting is when we originally ran that Docker run command right here, we specified a image tagged as 2.3 from Ruby. If you actually open up the Docker Hub page, so Docker Hub for that Ruby image we just made use of, so I'm going to search for Ruby and then go to the repository right here, you'll notice that there are a ton of other versions available, some of which are tagged as Alpine. So remember, a Alpine version of an image is essentially just saying, hey, this is a stripped down version of this image with just the bare minimum required to get this thing running. Now, in our case, we had to install a gem that did this extra build step. And like I said, that requires some extra packages to be installed with Ruby. If we had used the Alpine version of this Ruby image, this step right here would have actually completely failed. Because remember, the Alpine version is 100% stripped down. And so the Alpine version of the Ruby image does not have those extra packages required to do this step of building a native extension. So if we had used, I keep scrolling up because I think the command is up there, but it's not. If we had used an Alpine version, like say Alpine 2.3 right here, that gem install step would have failed because we did not have all the dependencies required to build this gem. So this is a great example where the Alpine version of an image is not always the best solution. Not always the best solution. Okay, I apologize for that little quick aside. I just had to mention it. I felt compelled, like I mentioned. All right, so it looks like everything successfully got installed. So now to make sure everything is set up correctly, I'll do the command Travis, like so. It's going to ask me if I want to install some shell completion. This is essentially some autocomplete stuff. We don't need it because we're just running like 1 or 2 commands here, so I'll just say no. And then after that, I'll get prompted here with the list of all the commands that are available to me tied to the Travis CLI. Okay, so Travis is definitely up and running successfully without us having to go through that long process of installing Ruby. Now let's take a quick pause right here. We're going to come back to the next section and we're going to continue going through a couple of other steps. So quick break and I'll see you in just a minute. In the last section, we installed Travis inside of a temporary container. We're now ready to log in to the Travis CLI so that it knows essentially who we are. Right now, inside the container, when we run Travis, we're just a random person and it doesn't know to associate any files or settings that we're going to load into Travis CLI with our personal Travis account. So to log into Travis, we'll execute Travis login like so. Now when we run that command, it's going to prompt us for our GitHub login information. As a reminder, when we initially signed up to Travis CI, we did not actually create a Travis account per se. We signed in using our GitHub accounts. So we need to make sure that we enter our GitHub login information here. So I'm going to enter in my GitHub username, and then I'm going to put in my password as well. Now on GitHub, I have 2-factor authentication set up, which means that I'm going to be texted a code to enter here to my phone. So I'm going to very quickly enter that. And there we go. I'm now successfully logged into Travis CI. All right, so now that we are successfully logged in, we need to make sure that we copy the JSON file that we downloaded from the Google Cloud dashboard just a little bit ago over into our volumed directory, which for us is the complex project folder. So we're going to copy that folder over so that we can access that file inside of our container. Okay, so inside of my downloads directory, I've got my folder explorer open. Here's that JSON file that I downloaded just a little bit ago. And then I've got a second window here inside the complex directory. This is the project folder that we're working out of, and it's also a folder that is essentially volumed or set up as a volume inside the container. So I'm going to drag this file over, like so. So that file now exists inside the complex directory. And then at the same time, I'm also going to rename that file just to make it a little bit easier to work with. So I'm going to rename the file to service-account.json, like so. So now if I go back over to my terminal and I do an ls, I should see service-account.json right here. Remember, you're only going to see this if you change into the /app folder. So if I print out my current working directory, I'm inside of the app folder inside of the container. So make sure you're inside of app, and once you are, you should see that service-account.json file up here. All right, so now that we've got that file inside of here, the last thing we need to do is run travis encrypt file, and we're going to specify the file that we want to encrypt. And there's one little addition to this command. We also need to specify the repository that we want to tie the encrypted file to. So it's going to look a little bit like this right here. There we go. So we'll do travis encrypt file service-account.json, and then we're going to add on -r, and then specify the exact name of the repository that we want to tie this encrypted file to. You can get the name of the repository right here by going back to the Travis dashboard and then looking at that project that we just tied to Travis CI. So here's that project that I just created over on GitHub. It's the same project we just tied to Travis CI. And so I'll see the entire name of the repository right here. So this is what we're going to enter into the encrypt file command. Now, the reason I'm showing you this in great detail is that your GitHub username is going to be case sensitive when you enter it into this Travis CI command. So you'll notice I have capital S and capital G. I need to make sure that I enter specifically capital S and capital G when I run encrypt file. Okay, so let's get to it. I'll do travis encrypt file. I want to encrypt the service-account.json file. And then I'll enter in the repository that I want to tie this encrypted file to. So I'll enter in my GitHub username. Notice how, again, I've got capitals here for my GitHub username. If you don't have any capitals in your GitHub username, then you don't need any capitals. I'm just saying it has to be case sensitive. And then I'll do a slash and the name of the repository that I want to tie this encrypted file to. In my case, I named the repository multi-k8s, like so. All right, so I'm going to run that command. It's then going to encrypt the file, and then I get a couple directions here. The first direction says that I need to add the following to my build script. So in the before install stage in my travis.yaml file. So I need to add this command right here to my travis.yaml file. This command is essentially going to take the encrypted file and then use the encrypted version of the file that is stored up on Travis CI servers and unencrypt it. So I'm going to copy that entire command. I'll then go over to my travis.yaml file, and then I'm going to add a new entry inside of my before install section here. So I'll add in a dash at the very start, and then I'll paste in that command like so. Now please triple check, make sure that the first part of the command says OpenSSL, and then the very last at the very end of this line should say -d, like so. Okay, now I can also look at the rest of the directions here. It says that I need to make sure that I add service-account.json.enc to my Git repository. If you list out your files and folders inside of this directory now, you'll see that it has created a new file inside of here called service-account.json.enc, enc standing for encrypted. So this is a encrypted file right here. It is safe to add to our Git repository. But the original file, the service-account.json file, not safe to add to my GitHub repository. So I'm going to open up my folder explorer again. Inside of here, here's the complex project folder. I see service account JSON and I see service account JSON encrypted. I'm going to make 100% triple sure that I take the original service account JSON file and I delete it. So really important, make sure you delete that. I'm even going to add a big note on here right now, just in case you're skipping through this section very quickly. I'm going to say very clearly, delete the original service account.json file. Please do that, I beg you. If you upload this file, someone will get into your Google Cloud account and probably nasty things are going to happen. So please, please, please delete the original file. So now if I do an ls after deleting the file, I should only see the new version, the enc right here. Again, this is the encrypted version of this file. It is 100% safe to upload up to GitHub and expose to the public at large. Okay, so that's it. That's the entire process. So I'm now going to exit out of this container by running exit. And now inside of my complex directory, because this was a volumed folder, I should see just the service account json.enc file. Now again, make sure you delete that original file. You have to delete it. I apologize for harping on this, but I know someone out there is going to forget to delete the file. So make sure you delete that thing. So now the last thing I'm going to do is I'm going to commit this added file right here. So I'll do a git add and a git commit -im. I'll say added encrypted service account file, like so. Okay, so that's pretty much it. So we've now encrypted that service account file and we are ready to make use of it inside of our travis.yaml file at some point in the future. So let's take a quick pause right here and we'll continue in the next section. In the last couple of sections, we went through the very long process of generating a service account and then encrypting the file and tying it to our Travis CI project. Now, I want to remind you one last time, please make sure you delete the original service account JSON file. So inside my complex folder, I should only see the encrypted file right here. So only enc, the old JSON file, totally gone. All right, so now that we've got this all set up, we're going to continue with our Travis YAML file. The next thing we need to do inside of there is to configure our SDK with the service account file that we just uploaded and encrypted. So I'm going to flip back over to my code editor and I'll find my travis.yaml file. Now in the last couple of sections, we added in that openSSL command right here. After this command runs, it takes that encrypted file and then it decrypts it and places it into our root project directory. So now, when we call gcloud auth activate service account right here and specify the key file of serviceaccount.json, that file has already been unencrypted and placed into our project directory. And so the gcloud command should see that file inside there with our real account credentials and be able to use that to get access to our Google Cloud account. So that's pretty much it with doing the initial setup of Google Cloud. Now we do have to do some additional setup. I only mean to say we finished the initial setup right there. So the additional setup we have to do, we have to tell the gcloud CLI exactly what project and what zone we want it to operate on inside of our Google Cloud account. Remember, in a single Google Cloud account, if you still have your dashboard open right here, we've got that project selector up here at the very top. So we have many different projects that we can work on inside of a single Google Cloud account. And so we need to tell gcloud exactly which project we want to work on. So to do so, I'm going to add on a new command of gcloud config set project, and then I'm going to put in my project name right here. Now, very important, your project name is not the simple project that you see right here. It's not multi-K8s. In fact, it's a little bit more involved project name. If you open up the project selector, you'll see the ID over here on the right-hand side. This is your real project name. And so in my case, my project name is really skillful berm blah, blah, blah. So I'm going to copy that ID, and then I'll put it back inside my travis.yaml file like so. After that, we need to specify a compute zone. So remember, Google Cloud, very similar to AWS, has multiple different data centers around the world. We selected a data center a little bit ago to use as our default for our cluster. So to get my default data zone, I'm going to open up my navigation menu over here. I'll navigate back to Kubernetes engine. And then right here, I see location of US Central 1-A. So that is my compute zone. And I need to also configure my Google Cloud CLI to use that compute zone as well. So I'm going to copy that location. And then I'll enter in another command here that says gcloud config set compute /zone. And then I'll paste in my particular zone, which again is US Central 1-A. And the very last configuration command we have to do, we have to tell the gcloud command exactly what cluster it needs to be working with if we issue any set of Kubernetes related commands. And so to do so, we need to add in the name of our cluster. So the name of my cluster is multi-cluster. So back over here, I'll put in gcloud container. Notice how this configuration command is different than the others. So I'll say gcloud container clusters get credentials, and then the name of my cluster, which is multi-cluster. So as you might imagine, this is going to tell the Google Cloud command to reach out to our multi-cluster and configure it to work specifically with that cluster. All right, so that's it. That's all the configuration we have to do with this gcloud command. So now at some point in the future, we're going to use it and the kubectl command as well to essentially update our cluster from a script that we put inside of either this Travis file or anywhere else inside of our project. So let's take another quick pause right here. When we come back to the next section, the next thing we have to do is log into Docker CLI, build the test version of our image, and run our tests. We've already gone through these steps before, so we should be able to get through them pretty darn quickly. Let's take a quick pause right here, and we'll continue in the next section. We are all done with our Google Cloud configuration, so the next thing we need to do is add in some stuff to log into our Docker CLI inside of our travis.yaml file. We've gone through this process before, and it's going to look identical to what we had previously done. So inside of my travis.yaml file, I'm going to add in another line to my before install script. I'm going to say echo $docker password, and then I'll pipe that into docker login -u, another double set of quotes with $docker username, and I'll specify that the password for this login will come from standard in, like so. Now this is a command we've ran before. Remember, we're making use of the docker login command. We have access to Docker because we specified it as a service inside of our YAML file. We're running login, and we're specifying the username right here, and then we're saying that the password will be emitted over standard in into this command. And we make sure that happens by echoing Docker password ahead of time. Now this assumes that we've already set up environment variables of Docker username and Docker password on our Travis dashboard. We did that in the past, but we did it on a different project. So we have to go through the same process again for the new project that we just linked up to Travis. So to do so, I'm going to open up my Travis dashboard again. I'm going to make sure that I'm inside of the multi-K8s project. This is the same one that we created a couple of videos ago. I'll go to more options on the right-hand side and then go to settings. Then inside of here, I can scroll on down to environment variables. Now you'll notice that we've already got some encrypted variables right here. These are tied to the encrypted service account JSON file that we set up just a couple of videos ago. So we definitely don't want to touch these at all. Now, as a quick side note, by the way, you might only see 2 keys inside of here, or 2 values. I have 4. The only reason you have 2 is because I actually recorded that section more than one time, and I set up these encryption things more than one time. So that's why I have 4 in here, and you probably only have 2. All right, so we're going to enter in 2 new key value pairs for our Docker password and our Docker username. So I'm going to enter in Docker username and then my Docker ID. Now, please remember to double check your spelling on Docker username right here. Bar none, the most common mistake that I see in projects that people make is they change the spelling of the environment ID right here, or the key for the environment variable, and they don't make it identical to whatever they put inside of the travis.yaml file. So please check your spelling on that thing. Make sure that it is identical to whatever you put inside the travis.yaml file. So then I'll add that, and then I'll do the same thing for my Docker password as well. And once again, please double check your spelling on Docker password. Make sure it is identical to whatever you put over here inside the YAML file. And then I'm going to get my password here very quickly. I'm going to copy it off a second screen, and I'm going to pull this tab onto my second screen very quickly and just enter my password over there. Because as much as I love you all and trust you all, I don't really want you to have my Docker password. Okay, so I've got my Docker password and my username safely encrypted inside of Travis, and I'm using those to log into the Docker CLI right here. So now that we are logged in, the next thing we have to do is build our test version of the multi-client image and then run our tests inside of it. Now these are 2 steps we've gone through before as well, so we'll go through these rather quickly. So back inside my Travis YAML file, I'm going to first build my image. So I'll do docker build-t. I'll tag it with essentially a temporary tag of React test, and I'm going to specify the Docker file to use for this with -f. Remember, we need to provide the relative path to our Docker file, and that Docker file is nested inside of the client directory. So for -f, I'm going to say /client dockerfile.dev. We specifically want the development version because only the development version of the Docker file has all the dependencies required to actually run our tests. And then after that, we'll also specify the build context on the very end. The build context is the client directory. So make sure you get the -f for the Docker file, and then the build context on the end. All right, so after that, we're all done with our before install section. So now we're going to define our script section, which is going to define how to run the actual tests for our project. So our test script is going to be identical to the one we had done previously. We'll say docker run your Docker ID, and we're going to specify the image that we just built a second ago. So the name of that image is React Test. And then I'm going to override the default startup command, and I'm going to instead run the command to run our test inside there, which is npm run test. And remember, we had to do that little trick of -- coverage like so, because by default npm test is going to enter a watch mode that's never going to exit, and it will not allow Travis to actually get any feedback from all this stuff. So by adding on the -- with -- coverage, it's going to print out a coverage report, which is going to give Travis a signal that either everything ran successfully or it crashed for some reason. Okay, so that's it for the script section. So we now have our tests running successfully. Now, as a reminder, we don't actually care about these tests one bit. They make no difference to our project. Again, I just wanted you to have a reference example right here and understand how you will run your tests on your own personal project. So on your personal project, you'll replace this with whatever command you need to run to execute tests for your project. And of course, if you're running a React project as well, you'll probably end up doing something similar. All right, so let's take a quick pause right here. When we come back to the next section, we're going to start to run a script that's going to deploy all of the latest images of our project. So quick pause, and I'll see you in just a minute. We've now installed our Google Cloud CLI, configured it, logged in with Docker, built our test image, and then ran our tests. So now we want to start focusing on doing our actual deployment, assuming that all the tests were successfully ran. Now, to actually do our deployment, we're going to write a script separate from the travis.yaml file. And inside that script, we're going to put in a series of commands that are going to build our images one by one, tag each one, push them to Docker Hub, apply all of our config files inside the K8s folder, and then do that imperative set image command for each of our deployments. So all this stuff right here, all going to be executed inside of a separate test file, or excuse me, a separate script file apart from our travis.yaml file. Now, why is this going to be in a separate file? Well, I want you to recall how we put together our travis.yaml file for the Elastic Beanstalk project. And I'm going to pull it on the screen here very quickly. All right, so here's the old travis.yaml file. And just to be really clear, I labeled it right here. This is old stuff from the last project, not relevant to what we're doing right now. So on our previous project, we put together the deploy section, and we specified a provider. When we specified the provider, that essentially told Travis to take all of our code and use this pre-established deployment script that Travis maintains to take all of our code and send it off to Elastic Beanstalk. Now, Travis does not have a similar built-in provider for deploying code off to a Kubernetes cluster. If we want to deploy to Kubernetes, we have to put together our own custom series of commands and tell Travis, hey, just run these commands for us. We'll take care of the deployment, just run these. So that's essentially what we're going to do. There is no built-in provider for Kubernetes. We have to put our own solution together from scratch. All right, so to do so, I'm going to open up my travis.yaml file for our project. Inside of here, we're going to put together our deploy section. But our deploy section is going to look a little bit different than the previous ones. I'll specify a provider of script, like so. So before we had said Elastic Beanstalk, this time we're saying script, which is telling Travis that, hey, don't try to do anything with our project. We'll take care of the deployment. Just run the script file for us. We then have to specify a command to run that's going to essentially be the script that we want Travis to execute. So I'm going to say bash./deploy.sh. So this is essentially saying that you and I are going to put together a custom script file called deploy.sh. And inside of that custom script file, we're going to write out a series of commands that's going to go through all those steps that we had just mentioned. Building our images, applying configs, and imperatively setting images on each deployment. So this right here, again, is what's telling Travis, don't worry about the deployment, just run this command for us right here, and we'll do the deployment ourselves. Now there is one other option on here that we are going to specify. We'll say on branch master. So remember, if we are pushing up some like feature or development branch, we probably don't want to execute this deploy script. We only want to do our deployment if we are pushing up branch master. So only if we're working on the master branch do we want to run this command right here, which is going to run that deploy script file and attempt to deploy all of our new images out. All right, so now the last thing I want to do in this section is very quickly create this deploy.sh file inside of our root project directory. So inside the root project, I'll create deploy.sh. So again, inside of here, we're going to put together our series of commands that's going to build the images, tag them, push them, apply configs, and so on. So let's take a quick pause right here. When we come back to the next section, we're going to start filling out our implementation for our deploy script. In the last section, we created a deploy.sh file. So inside this file, we have to do our image building, apply some configs, and imperatively set the latest images. Now, I've repeated this series of 3 steps right here like 5 or 6 times, and I'm sure you're tired of me saying it. The reason that I keep talking about these 3 steps right here is that it's actually going to be a little bit more challenging than it might seem at first glance. So we're going to do kind of an initial take on these steps right here. And then as we start to go through a couple of these steps, we're going to very quickly realize that there's a little bit of an issue with some of the config that we'll put together for these steps that you would think would be reasonable. So in other words, we're going to write out what's going to seem like the right code or the right commands, but at the end of the day, something's going to be just a little bit off. All right, so let's get to it. Inside my deploy.sh file, we're going to first write out a series of commands to build each of our different images and then push them each off to Docker Hub. So I'm going to do a Docker build. I'm going to tag it. I'll put in my Docker ID. We'll do our multi-client first. I'll specify the Docker file location, which is /client Dockerfile. And then I will also specify my build context of /client. Now I'm going to zoom out for just a second so you can see that entire line. Okay, so there it is in entirety. Now I'm going to do the same thing twice again, once for our server image and once for the worker. I encourage you to not do a copy paste here, because if you do a copy paste, incredibly likely that you might forget to change one of the mentions of client inside of here. All right, so we'll do a Docker build, Docker ID, multi-server, server, Docker file, and server. So now at this point, I want you to double check 3 locations. 1, 2, 3. Those should all say server. Should not see any mention of client on the second line. And we'll do the same thing a third time around. So I'll say Docker build -t, worker, get the worker Docker file, and then finally specify the build context of worker as well. And so now, again, I want you to triple check multi-worker, worker, and worker. Cool, so that looks good. Okay, so that is us building our images. So now the next thing we have to do is take each of those images and push them off to Docker Hub. Now we've already logged into Docker through our travis.yaml file. The Docker command that we're using right here is the same Docker that we're kind of configuring back inside the travis.yaml file with the Docker login command. Wherever we put that, here it is right here. So we don't have to log in again or anything like that. We can just freely take each of these images and push them off to Docker Hub. So I'll do a Docker push, my Docker ID, multi-client, and then I'm going to repeat the process 2 more times. And let me zoom in now, since we're looking at a very shorter line here. So I'll do Docker ID, multi-server, and finally multi-worker, like so. Okay, so yeah, it still seems like everything is looking pretty good. Let's go back over to our diagram over here. So the next step after building and pushing those images is to take all the configs in the k8s directory and apply them. Now remember, inside the travis.yaml file, we already configured Google Cloud, and Google Cloud is in charge of our kubectl command inside of this Travis environment. So we don't have to do any more configuration of kubectl. We can just write kubectl commands in the exact same fashion as though we were running them on our own local machine. And so to take all of the different config files inside of our k8s directory, we'll simply do kubectl apply -f k8s. So take everything inside that k8s directory, apply all those config files. Okay, so now the last step we have to go through, imperatively set the latest image on each deployment. So this is where things are going to start to get really interesting, and we're going to very quickly see that there's a little bit of an issue with what we are doing here. So remember how we set a image forcibly or imperatively on a deployment. We do it by writing out kubectl set image. Then we'd reference the object type that we want to update. Then the name of our deployment, which in our case for the server is server deployment, and we can get the name of that from our k's directory. Here's the server deployment file right here, and we had given it a name of server deployment. So that looks good. So we're saying deployments server deployment, and then we select the server container, and we tell it to use the image my Docker ID / multi server, like so. All right, so I want to look at this configuration that we just put together and notice how we're not going to do the last two or the other two deployments in here just yet, because I want to point out something that is not quite correct with how we've written out this command right here and the entire series of commands inside this file. Don't worry, I'm not saying we have to rewrite the entire file. I'm just saying that there's one or two little things inside of here that we need to tweak. So I want you to think about what's going on inside of that deploy file right now. At the very top, we're essentially saying, okay, let's do our Docker build, and then we tag our image, like in this case, it's the multi-client, with just the name, whatever my Docker ID is, / multi-client. And so the result of this entire command right here is an image with the command, or excuse me, the tag, Docker ID multi-client. And remember, anytime that we build an image, if we do not specify a tag, the implicit understanding is that it gets automatically a tag of latest applied to it. In fact, you can actually double check that right now if you check out your Docker Hub account. So if you go to hub.docker.com and look at your multi-client image, look at tags, and you'll see inside of here, here's latest. So I've got some other versions that we had put together previously, but essentially right now, the latest copy is tagged as latest. That is the implicit tag that is assigned to any image that I build and push off to Docker Hub. So what's that mean? Well, it means that later on, when we run docker blah blah, or excuse me, kubectl set image blah blah blah, and then specify the multi-client image, that deployment, and this is something that we ran into previously, remember? That deployment looks at the image that is specified. It sees Docker ID / multi-client, and then maybe we add on :latest here, maybe we don't, doesn't really matter either way. Essentially, the deployment is going to look at that image name, and it's going to say, oh, I was already running the latest image, so I don't have to make any change whatsoever. Remember, we spoke about this at great length earlier on inside the course. We had spoken about the set image command. We had spoken about how there's a couple of different ways of somehow telling a deployment to update the version of an image that it uses, and we had eventually landed on saying that we were going to use an imperative command to update our deployment. So we had said that the entire flow was going to be something like this. We were going to change our, well, this was a very particular workflow right here, but we had essentially said that we were going to update the multi-client image, and we were then going to, very importantly, tag the image with a unique version number and push it up to Docker Hub, so that sometime in the future, when we use kubectl to set the image that the deployment used, we could specify a very particular version of that image, so that the deployment would say, oh, okay, I see you've applied some new version here, or it's a image name that is different than the one that I'm currently running, so an update is required. So essentially the issue with all the deployment commands we put in here so far is that we're kind of operating under the assumption that all these images are using that latest tag, and as soon as we set an image with the latest tag on our deployment, the deployment's going to say, I'm already running latest, no change required. All right, so now that we remembered this entire situation, because we did cover it quite a bit ago inside this course, let's take a quick pause. When we come back in the next section, we're going to talk about how we can get some version numbers to be automatically applied to all of our different image tags, and how we can essentially solve this entire issue with making sure that our deployments really get the latest version of these images. So quick pause, and I'll see you in just a minute. In the last section, we got a reminder of something that we covered much earlier in the course. Remember, anytime that we set an image manually on a deployment, we have to make sure that we use some image name or some tag on it that is unique and different than what the deployment is currently running. If it is not different, then the deployment is just going to say, oh, no changes, I do not need to update myself. So in this section, we're going to figure out how we're going to work around this issue without having to always manually specify a version, as we did previously. Remember when we initially discussed this problem and we ran this kubectl set image command, we had manually set on a version number of something like version 2 or something like that. And so of course, we don't want to have to manually set version 2 or some text on here. We want to have this be something that is done automatically. So let's talk about how we're going to do this. All right, here we go. So I took the same command that we were just looking at a second ago, the docker build command, but I put it on multiple lines here just so you can read it a little bit more easily. So when we run the docker build command, we're going to apply 2 separate tags to that image that gets created. So it's the same image, it's just going to have 2 tags applied to it. The first tag that we're going to apply is the same one that we're already applying, which is the multi-client latest. Now, to be precise, the current version of our deploy file does not have latest on there. We are going to go back and add it on. And we'll talk about why that's going to be on there in just a second. Now, more importantly, to get some unique version identifier, we're going to add on this second tag of your Docker ID, multi-client, and then a git SHA. Now, just in case you're not familiar with what a git SHA is, let me give you a very quick demonstration. If you flip over to your terminal right now and are inside the complex directory, remember that we have set up a Git repository to track all the changes we make to files inside this folder. Anytime we make a set of changes and then want to send those changes up to GitHub, we have to create a commit. With every commit that we create, a unique identifying token, referred to as the SHA, is generated. And that SHA is essentially identifying that current set of changes inside of our codebase. So to print out the SHA that we are currently working with right now, you can run git rev parse head, like so. And that's going to print out the current SHA for the latest commit that I put together. We can also do a git log, and that will print out all the different SHAs for all of the different commits that we have created over time. So we can essentially imagine that this SHA right here is a absolutely unique identifying token that's always going to be different, and it identifies the state of our codebase at a very particular point in time. And so that it makes it absolutely perfect to use as a version identifier for our images. So we're going to put the git SHA into our tag for the image. So when we get an image out of this thing, we're going to have the 2 separate tags, both multi-client latest and multi-client followed by a SHA. Now, when I put the $SHA right there, I don't mean to say we're going to literally say $SHA. I mean to say it's going to look a little something like this. Like so. So essentially, $git SHA up here means that we're going to determine the current SHA and append it onto the end of the tag. So when we eventually get a tag out of this thing, it's going to look something like this right here. So then at some point in time in the future, when we try to set our image on our deployment, we'll be able to provide an image name with a version tag on it of something like that. And the deployment, of course, is going to see that unique token right there, and it's going to say, oh, this is some new version of the image. I'm definitely going to update myself and create a new set of pods using this new image. So that's the idea. We're going to use our git SHA here. Now, besides just being a way to uniquely identify the current image or the current version of the image that we're using, there's actually another benefit or two around using the git SHA. I want you to imagine for a second that we go through this deployment process and maybe we deploy our app several times. And then at some point in time in the future, we go and visit our website and we realize that it's completely broken and it's just not working the way we expect. And so, of course, we would want to immediately do some debugging. Probably we would want to figure out exactly what code we are running inside of our Kubernetes cluster, or essentially what exact state of the code base is inside of all the different images that are inside the cluster. So in order to debug a broken cluster or something running some really bad images, here's what we could do. We would say, oh no, our app is breaking. We need to figure out the exact state of the code base that the deployments are running. In other words, give me the exact version of that client image so that we can debug it locally. So we could run a command to figure out exactly what image the deployment is running. So it might say, okay, we're running multi-client version 83B, whatever it is. So then back inside of our local repository, we can run git checkout with that commit SHA. And that will revert our code base back to the old version or the version of code that is currently running in our deployment. So then we could then debug our application locally, knowing that we are debugging the exact same code that is running inside of our production environment. So when you start using these git SHAs as a way of tracking your deployments, you do get some really good benefits. Now, the last thing I want to mention here very quickly, you might be curious why we are still going to apply the latest tag to our image that we are building here. So yes, we are going to put the two separate tags on here, but why are we still going to put on latest? Well, here's why. I want you to imagine that we run this command, with latest and get SHA, we build our images, we push them up to Docker Hub, whatever happens, and then at some point in time, maybe some new engineer comes onto your project. And so some new engineer comes along, they clone your repository, and then they run the command kubectl apply k8s. So they're going to take all the different config files inside the k8s directory and apply them to their local copy or their local Minikube cluster for Kubernetes. Now the deployment files that we have specify an implicit latest tag. And what I mean by implicit is that inside of all of our different config files for our deployments right now, if we open up, say, the client deployment, we have an image right here of multi-client. So again, the implicit understanding, or what Kubernetes is going to do automatically, is pull down the latest version. We don't have to specify latest, it's just going to do that automatically. So when this engineer, this brand new engineer, runs kubectl apply k8s, and all of our deployment files specify essentially the latest tag, then we're going to automatically be giving this new engineer the latest version of each of those images, and that engineer does not have to worry about somehow getting the current commit SHA and specifying that particular image for what they want to apply on their deployment. So that's why we are doing both here. We're doing the SHA to make sure that we can correctly update stuff in production, or inside of our cluster. And we are still doing the latest to make sure that if we ever have to reclone or rebuild our cluster at some point in time, we always know that the latest tag image is truly the latest version of our image. And we don't have to go and try to track down like what our current SHA is or anything like that. Okay, so I know this has been a long discussion about how we're doing all this build stuff. I think we have a good idea of what's going on now. So let's take a quick pause right here. When we come back to the next section, we're going to start to update our Travis YAML file and the deploy script to incorporate this idea of using our git SHA. So quick pause, and I'll see you in just a minute. In the last section, we had a long discussion talking about how we're going to uniquely tag each of our images. And the first thing we need to do is add some code to our travis.yaml file that's going to determine the current git SHA for our repository and export it as an environment variable so that we can later on use it inside of our deploy file. I'm going to flip over to my travis.yaml file, and up at the top, right after our services section, I'm going to add on a new section called env. And then inside there, I'm going to specify global. And inside of here, we're going to set up some number of environment variables. So the environment variable that you and I care about is getting the current commit SHA. And I want to store that as an environment variable called simply SHA, so that we can easily refer back to it in the future inside of our deploy.sh file without having to run that git revparse command again and again and again. So inside of here, I'll say get SHA. Actually, well, let's keep it simple. We'll just do SHA. So that's going to be $ parentheses get rev parse head. So this right here is going to determine the current commit SHA and assign it to an environment variable inside of our Travis environment alone called SHA. So we can now freely access this environment variable inside the deploy.sh file. Now, while we're inside of this environment variable configuration block right here, there is actually one other environment variable that we need to specify. This is totally unrelated to all the SHA stuff. I just wanted to make sure we took care of both these environment variables at the same time. So the second environment variable that we're going to put together is cloud SDK underscore core disable prompts equals 1, like so. So Cloud SDK, this entire thing right here, is just going to configure the Google Cloud CLI and make sure that it does not try to display any prompts that require user input. So in other words, when you and I run this command, gcloud auth activate service account, if this thing normally presents some warning or something that says like, are you sure you want to do this? Press Y or N. We don't want to see that because you and I don't have the ability to respond to that in a Travis environment. And so this right here is just going to make sure that the Google Cloud CLI does not try to show us any prompts such as that. Now this is kind of a tricky command to write out here, so please make sure that you spell everything in this correctly and that everything is capitalized inside there. All right, so again, I apologize for that kind of little sidetrack, but again, I just wanted to do all these environment variables at the same time. All right, so we're going to flip back over to our deploy.sh file, and we're going to start to make some changes to this thing now to make sure that we apply not only a latest tag to all of our build images, but the git SHA as well. All right, so I'm going to first start with the client. Now here's the -t, my Docker ID multi-client. I'm going to append to that latest, like so. So this is just going to be 100% clear that we want to tag this image as the latest version. After that, I'm then going to add on a second tag. So this is where this file is going to get a little bit squirrely, and there's going to be a lot of text moving around here. So we're going to say -t, so a second tag, your Docker ID, /multi-client, colon, and then $SHA, like so. So now in total, Docker build, tag 1 with latest, tag 2 with our SHA that we had defined as an environment variable inside the travis.yaml file. And then after the second tag, we should still see the -f for the Docker file and the build context on the end. Okay, so we're going to repeat that process twice again. So on multi-server, I'll add on :latest, and then we'll do another -t, multi-server SHA. So again, double check this line. We've got tag 1 with latest, and then tag 2 with the SHA. So then finally, we'll do latest on the multi-worker SHA. All right, so tag 1 and tag 2. Again, do make sure that we have client server worker. So make sure you did not accidentally put like server in there or anything like that. We have client server worker, client server worker, client server worker, client server worker, all the way down. Okay, so that's looking good. Now the next thing we need to do is make sure that we push these new tags off to Docker Hub as well. So unfortunately, when you do this Docker push right here, we are pushing very specific tags as opposed to an image and all the tags that it has. So we have to run Docker push not only for multi-client latest, but also for multi-client SHA as well. So for each of these different tags we have, we're going to have 2 separate push commands. So I'm going to look at all the current pushes we have right here. And I'm going to put on latest to each of them just to be 100% explicit. And then I'll do another set of push commands. Now for this one, I am just going to do a copy paste, no harm in this case. So there's my copy paste for client server worker. And then I'll update each of these to be SHA, SHA, and SHA, like so. So now the last thing we have to do is make sure that we get a separate set image command for each of our different deployments. And we need to make sure that we specify multi-server with our git SHA on the end as well. And so for the first set image right here, I'm going to go to the very end of the line. Here's multi-server, and I'll append on :SHA, like so. And then we're going to repeat this command twice again for the multi-client and the multi-worker as well. So I'll do kubectl set image deployments, client deployment. Client is going to be my Docker ID. Multi-client, and I'll put the SHA in. And then finally, we'll do the same thing as well for kubectl set image deployments, worker deployment, and the worker image, or excuse me, the worker container inside that deployment needs to use the image my Docker ID multi-worker :SHA. Okay, so that's it. That's all we have to do. Now that's the entire deployment script here. Now again, I gotta ask you, please do one last quick triple check inside of here. Make sure you've got client server worker, client server worker, server client worker, server client worker, server client worker, all the way across. No one of these lines should have like duplicated client in a row like so. They're all completely separate images that we're working with here. Okay, so that's pretty much it for our deploy.sh file. And I think that's pretty much it for our travis.yaml file as well. So we're just about ready to push this thing off to GitHub and test out our deployment. But before we do, there's one or two last quick things we have to take care of inside of our Kubernetes cluster on Google Cloud. So let's take a quick pause right here, come back to the next section, and one last little piece of setup we have to get to. So I'll see you in just a minute. We're all done with our travis.yaml file and our deployment script, but before we try to deploy this, there's one or two little last pieces of configuration we have to put together on Google Cloud. Now I'm on my dashboard right here, and I'm making sure that I've got my multi-K8s project selected. Now let me give you a quick reminder of something that we did previously in our local environment that we have to manually do on Kubernetes on the cloud as well. So one thing we had previously done was create a secret. We had created a secret to make sure that the multi-server had a PG password environment variable. This environment variable of PG password was encoded into a Kubernetes secret and then shared with both the multi-server and our our Postgres image as well. In fact, if you open up your code editor right now and find your K8s server deployment file, at the very bottom, you'll recall that we had hooked up our secret to this thing with a name of PG password for the secret. And the secret contained a key of capital PG password as well. So we need to make sure that we set up an environment variable, or a secret, just like this one on our remote Kubernetes instance as well. So this cluster does not currently have a secret assigned to it for that PG password. We have to manually create one by running that kubectl create secret command. Now this is one of the very few instances of an imperative command that we have to run. Remember, we did not create a config file for the secret because that would kind of defeat the purpose of using a secret in the first place. With a secret, we specifically do not want to put that thing in plain text inside of our repository. Okay, so all we have to do is essentially get access to a kubectl instance that is connected to the multi-cluster hosted on Google Cloud. Now to do so, we do not have to reconfigure our local kubectl command or anything like that. So we're not going to reconfigure this command or anything. Instead, we're going to make use of a really awesome feature on Google Cloud. So up at the top right-hand side of your dashboard, I want you to find this little Activate Cloud Shell button right here. If you click it, you'll then very quickly be connected to a terminal or a shell that is essentially running in the context of your Google Cloud project. So inside of here, we can issue any set of commands against all of our production resources. We can make use of kubectl and have this kubectl command apply to our multi-cluster that we just created. And so we get to run all the same commands we had previously ran back on our local machine through this little terminal or the shell right here. This is really one of the features that makes Google Cloud a lot easier to use and a lot easier to get started with than AWS. Now, to be honest, with AWS, you can set up something similar by reconfiguring your local shell on your computer, or you can SSH into one of your Kubernetes clusters that is hosted by AWS, but the entire process of that is way, way, way more complicated than just pressing the button up here and essentially being done with it. Okay, so we're going to run our kubectl create command right here. Before we do, we need to do just a tiny little bit of configuration. So back inside of our travis.yaml file, remember how we installed the gcloud command right here, the Google Cloud SDK, and then we ran the series of commands right here to config and set our project and our compute zone, and then eventually get a set of credentials for multi-cluster as well. We have to do the same thing on this shell over here as well. So we need to set our project ID, we need to set our compute zone, and we need to get those credentials too. So to do so, I'm going to first zoom this in a little bit so you can see it more easily. We'll first run gcloud config set project, and then we'll get our project ID by going up to the project dropdown up here, and then finding the ID right here. So I'm going to copy that, and I will paste it. Try it again. There we go. Paste it in. So gcloud config set project and then the ID. Okay, so that looks good. Now the next thing we need to do is set our compute zone. Remember, if you go to your Kubernetes engine dashboard and you look at your cluster, it'll print out the location right here. That is our compute zone. So I'll do gcloud config set compute /zone. And then for me, I'm going to use US Central 1-A. US Central 1-A. Cool, that looks good. So now the last thing we need to do is that get credentials command. So gcloud container clusters get credentials, and then I'll put in the name of my cluster, which is multi-cluster. Cool, so that's pretty much it. Now, just so you know, you only have to run this series of commands right here one time, unless you create a different Kubernetes cluster at some point in the future or a different project. Every time you create a separate cluster or a different project, you're going to have to rerun that series of commands. So in general, for the rest of this course, we're going to be okay, but if you go off and start working on your own application at some point in the future with a new cluster, you're going to have to run those again. And as a very easy reference, you can just go back to the travis.yaml file and reference these 3 commands right here so that you know what to run in the future. Okay, so that is going to configure gcloud, so we can now use kubectl safely inside this shell. Let's take a quick pause. When we come back to the next section, we're going to use kubectl to create a secret tied to our cluster. So I'll see you in just a minute. In the last section, we configured the gcloud CLI on our Cloud Console. We can now test out our connection to our production Kubernetes cluster right here by doing something like kubectl get pods. When I run that command, I should eventually see something come back that says no resources found, because of course we have not yet created any pods inside of our Kubernetes cluster. But this is at least demonstrating that, yep, it is in fact connected to our Kubernetes cluster, and that means we can use kubectl right here to issue different commands to, say, create a new secret or do whatever else it is that we need to do. So again, for us, we want to create a secret, so we're going to do kubectl create secret generic. Our secret name is PG password, all lowercase. And I know that because of my server deployment config file back here. So the secret name is PG password, lowercase. And then we'll say from literal, and then we'll use capital PG password equals, and then whatever password you want to use. Now, this is the initial setting of this password. It does not have to be the same as your development password. And in fact, it should very likely be different. So we can make this password anything we want it to be. All right, so I'm going to go back over here, and I'll do kubectl create secret generic. And I'm just going to double check here, because I have a short memory sometimes. Create secret generic, yep. And then our secret name is going to be lowercase PG password, -- from literal, and then capital PG password equals, and then whatever password you want to use. So for me, I'll do something like, I don't know, my PG password 123, whatever. Okay, so I'm going to run that command, and I'll see that the secret was created. So now something that's kind of interesting, if I drag that little interface down and refresh this page, it might ask you to reload, which is totally fine. I'm going to reload. And then I'll open up the configuration tab over here, and we'll see that the secret has now been created and is available for use inside of our application. Cool, so that looks pretty great. Now there is just one other thing we need to do before we get to our deployment. So let's take a quick pause right here and take care of it in the next section. There's one last piece of configuration that we have to set up on our production Kubernetes cluster before we can actually deploy our application. If you open up your code editor right now and find your K8s directory, you'll recall that we had set up that ingress service. And the ingress service relied upon the ingress nginx project, which we had installed into our local Minikube cluster through the use of that Minikube add-ons enable ingress command. It was specifically that command that allowed us to use this nginx ingress into our local cluster. Now we have to go through a very similar setup on our production Kubernetes instance as well. So by default, the cluster that we just created right here has absolutely no idea of what a Kubernetes, or excuse me, a nginx ingress is, and we have to install it as a separate service. Now, as a quick reminder, when we install that ingress, we're going to get a couple of things created for us. First off, we've got the ingress config, which is that ingress config file we've already created inside of our project. But we have to go through that additional setup that is going to create the load balancer service, map it to a Google Cloud load balancer, and then also set up a deployment running the ingress controller and the actual nginx pod that's going to do the real routing. So this is all some additional setup or some additional installation process above and beyond everything that we've already done. Now, to get the setup directions for this, we can go back to the documentation for the ingress nginx page. So the URL for that right here. Remember, we do not want Kubernetes ingress. We want ingress nginx. And so I'm going to copy this URL right here, github.com/kubernetes/ingress nginx. And I'll open that in a new tab inside my browser. Now at the very top of this GitHub repository is the home page for this project. So I'm going to go there right now. And then at the top of this page is a section marked as deployment, which has directions on deploying this project out to either a local or production environment. So I'll go to deployment. And then inside of here, you'll recall that there's both the mandatory command and the provider-specific commands on here as well. So if we wanted to, we could use this mandatory command, but we're going to do things a little bit differently this time around. If you go back up to the top here and look at contents, you'll notice that down at the bottom, the very last option is using Helm. So let's talk about exactly what Helm is. I'm going to click on that link, and it says right here that the controller can be installed using Helm. So what's Helm? Well, really straightforward. Helm is essentially a program that we can use to administer third-party software inside of our Kubernetes cluster. So just as we've been talking about, yeah, we want to get some outside software into our cluster, like this outside deployment and the pod that it controls, we want to install that as a third-party system essentially. And to do so, we can either manually run all those apply commands with all those configs that are mapped up to them that we just saw inside the official documentation over here. So like all these apply commands that we've seen, but we can also make use of this command line tool called Helm. Helm is very commonly used with some of these more complicated projects where some of the setup might be a little bit challenging in nature. Now you might be thinking that there's nothing wrong whatsoever with using this very simple apply command right here that we had ran previously, and using the very simple apply command with GCE right here. Those look like they're really straightforward, but in this case, we're going to use Helm instead because something that we're going to do a little bit later on is going to absolutely positively require us to use Helm. So this is a pretty good opportunity to get this thing set up and understand exactly how it works. Now, if you want to read some of the documentation on Helm, you can go to github.com/helm/helm. When we install Helm, we're going to actually get two separate pieces of software. The first is called Helm, and we refer to that as the client. In addition to the Helm client, which is essentially a CLI tool that we're going to issue commands to, we're also going to be installing something called Tiller. Tiller is a server running inside of our Kubernetes cluster, and it is what is responsible for modifying our cluster in some fashion and installing additional objects inside of it. You can really think of the relationship between Helm and Tiller as a relationship between the Docker client and the Docker server running on our machine. Very similar relationship. All right, so we're going to walk through the installation process for Helm in this section, and then after that, we'll take a quick break and start to walk through some configuration of the Tiller server, because it is going to require a little bit of extra setup. So to get started, I'm going to navigate to github.com/helm/helm. Oops, Helm. There we go. And then on this page, we're going to go to the official documentation. The link is right up here at the top, but do know that there is other information inside of this README right here that you might want to be aware of. In fact, even says right here, hey, two parts, a client and a server, Tiller. Okay, so we'll go to helm.sh, and then on the top right-hand side, we'll find Git Helm. Oh, God, I forgot about that. It just links you back to the GitHub page. Okay, we're going to try this a different way. We're going to go down to the README, and down here, it's going to talk about install, and we're going to go to the quick start guide right there. That's better. All right, that's what we're looking for. So if you can't find that link on the README, I'm going to update the link on my diagram over here real quick, just so you can get to the same page as well. Okay, so on this page, we're going to go through one of these install directions. Now there's a lot of different ways of installing Helm because it assumes that you might be running Helm in production or you might be running it on your local computer. So one of the preferred ways that it lists inside of here to install Helm is it's going to say, oh yeah, you should install using Homebrew, which is a tool for installing software on a Mac OS machine. And clearly, we probably do not have access to Homebrew in our production Kubernetes environment, so we cannot use this preferred method. So instead, we're going to scroll down a little bit, or maybe a lot. We're going to go down, down, down. So here's the installing Helm section. You could also get here by clicking the link on the left-hand side. And then we'll go a little bit lower here, a little bit lower, a little bit lower. There we go. So from script, this is what we want to do. If you can't find this section, you can, of course, just do a Control F and search for from script like so. So to install Helm, we're going to copy these 3 commands right here and run them inside of our Cloud Console on Google Cloud. So I'm going to take the first command right here, not the $, I want just the curl. I'm going to copy that, and I'll paste it over here inside of my Cloud Shell. That's going to download that script. We then need to change the permissions for the script that we downloaded by running change mod. So I'll copy that. We'll run it as well. And then finally, we'll execute the script with /gethelm.sh. Okay, so that's going to do a little bit of setup, and then very quickly you'll see, okay, everything's good to go. Now it says right here, run Helm init, but I got to tell you, do not run Helm init yet. So we have to do a little bit of extra setup because we are running on Google Cloud. If you want to read about this extra setup, there's actually a section inside of this quick start guide. I think it might be just a little bit down here. Installing Tiller, yeah, it's right here. Right, next one. Oh, come on, I know it's in here. Oh, gee whiz. Okay, we're just gonna do a search for it. Google Cloud. GCE, GKE, there we go. So on the GKE section right here, who knows where it is inside the document, do a Control F. You'll see that it says, hey, you need to do a little bit of extra setup here. So we're going to take a quick pause right now. When we come back to the next section, we're going to go through this additional little bit of setup to make sure that Tiller gets set up correctly on our Kubernetes cluster. So a quick break, and I'll see you in just a minute. In the last section, we installed Helm, and then we eventually said, hey, wait, we need to do some additional setup because we're running everything on Google Cloud. So this little note inside the Helm documentation says that Google Cloud Kubernetes enables something called RBAC by default. So in this section, I want to have a quick discussion on exactly what RBAC is and why it's going to make us have to change the way in which we set up all this Helm and Tiller stuff. So we're going to look at a couple of different diagrams here. Now, I know by this point in the course, you're probably thinking, oh my gosh, let's just deploy this thing and be done with it. And so I'm sure the fact that I threw Helm in here at the very end is probably making you think, oh my gosh, like, why more stuff? But trust me, we're almost at the end. We just have a couple more commands to run, and then we'll be able to deploy everything and we'll be good to go. So almost at the end. All right, so a couple diagrams. Now, first thing I want to remind you, because it's going to be really important as we go through this, we just installed Helm. Helm is a reference specifically to the Helm client, which is like a CLI, something that you and I are going to issue commands to. Helm, in turn, is going to take those commands and relay them off to Tiller. Tiller is a pod that is going to be running inside of our cluster, and this pod running Tiller is going to attempt to make changes to the configuration of our cluster. In other words, it's going to try to install new sets of configuration, new sets of deployments, new secrets, whatever else it might be. All right, so with that in mind, I now want to tell you a little bit more about RBAC. So RBAC stands for Role-Based Access Control. The purpose of RBAC is to limit who can access what different types of resources inside of a Kubernetes cluster. Inside of our local development environment of Minikube, the RBAC system was not enabled by default. So in our local environment, essentially you and I, or any pod, could access the cluster directly and arbitrarily change configuration. In other words, we could create a pod inside of our cluster locally, the local cluster, that tried to access the Kubernetes cluster and arbitrarily create new sets of pods or new deployments or new secrets, or delete stuff if it wanted to. Now, as you might imagine, in a production environment, we generally like to kind of lock things down and make sure that unauthorized users or programs do not have the ability to change the configuration of our cluster. So the RBAC system is all about making sure that we have the ability to limit who can do what inside of our cluster. Now, like I said, locally with Minikube, RBAC is not enabled. Google Cloud enables RBAC by default. So in production, we have to deal with this security system. Now, the obvious thing that I want to point out here is that, as I just said, the purpose of Tiller is to attempt to modify the configuration of our cluster. That definitely sounds like something that might go against this role-based access control. Tiller wants to make changes to our cluster. It wants to create things, delete things, modify things. And so we need to make sure that Tiller has the correct set of permissions so that it can actually make all these different changes. And so when you go back over, if you still have the Helm documentation up here and you see Tiller and role-based access control for more information, that article right there is essentially going to say, yeah, we need to make sure that Tiller has the ability to make all these different changes. All right, now that's just the RBAC system. The RBAC system has a lot of intricacies to it, so I want to go a little bit deeper in and give you just a little bit more context so that you're going to eventually be able to understand the different commands that you and I are going to run to allow Tiller to make changes to our cluster. So a couple pieces of terminology here. So this is really two sets of definitions, 1, 2, and 3, and 4. And the first thing I want to talk about is user accounts. Whenever you and I, as human beings, access our Kubernetes cluster, we are making use of the kubectl command to essentially change settings inside of our cluster. And as you can probably guess, if you and I wanted to right now on our Google Cloud dashboard or the Cloud Shell right here, we could do something like kubectl create pod, blah, 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 whatever we want to do. And we're probably not going to see any type of warning or security error saying, hey, you're not allowed to do that. So you and I, as users, have the ability to easily log in and access kubectl and make changes to the state of our cluster. Now, we are able to do that because of our user account. The user account is something that identifies us as a human, a person, administering our cluster. If you were working in a large company that has a ton of different workers who are supposed to be administering a Kubernetes cluster, you would probably create a separate account for each of those different employees. And so you can keep a log of who is modifying what inside of your cluster. Now, in a very similar fashion, a service account is going to identify a pod or a program inside of your cluster. So whereas a user account belongs to a person, a service account belongs to a pod or some type of process running in the cluster. Now, the important thing to understand here is that a user account and a service account alone does not allow a user or a pod to make changes to a cluster. These accounts simply identify a person in the same way that your Google account just like, say, identifies you as a person. Getting the actual ability to make changes to the state of your cluster or to change configuration is granted by these role bindings. So the role bindings are all about authorization. A role binding allows you to actually do something. We create role bindings and then we assign them to either a user account or a service account. So a user account or a service account identifies you. It is only a role binding that gives you the ability to do something. Now there's two types of role bindings, a cluster role binding and a role binding. Both of them will allow you to have an authorized set of actions that you can make inside of your cluster. The only difference between them is that a cluster allows you to make changes across the entire cluster. So everything inside the entire cluster, you can make changes to through the use of a cluster role binding. A role binding, on the other hand, is only going to allow you to do a certain set of actions in a single namespace. Now, we haven't spoken about namespaces too much inside this course, but as you might be able to guess by the name and the little bit that we have discussed about them, whenever you create a cluster, we'll do a command right now, kubectl get namespaces. Some number of namespaces get created for you automatically. So by default, we always get default, kubepublic, and kubesystem. Kubesystem contains a bunch of different Kubernetes objects that make your entire cluster work the way you expect. So kubesystem is essentially kind of an administration level that makes sure that everything is doing what it's supposed to be doing. If you want to, you can isolate different sets of resources into different namespaces. And so you might, for some reason, want to create a role binding that only allows a particular service account or a user account to make changes to objects in a single particular namespace. That's very much outside the realm of what you and I are doing by a huge degree. I just wanted you to know that that does exist. So for you and I, we want to make sure that this tiller thing has the ability to make changes across the entire cluster, and it needs to be able to have those permissions assigned to some pod, essentially, or program inside of our cluster. So as you might guess, we need to create a service account, and we need to create a cluster role binding, and then tie that cluster role binding to that service account. We'll then assign the service account to that tiller pod. So that tiller has the ability to change anything that it wants to across our entire cluster. Now, if you had big concerns around security, you could definitely change this up. You could definitely create a service account and assign it to tiller, but then instead assign it a role binding so that maybe tiller is only able to make changes to a very specific namespace. But for you and I, we want to allow tiller to do anything it wants, so we're going to give it a cluster role binding that says essentially, here you go, do whatever you want across the entire cluster. Okay, so with that in mind, let's take a quick pause right here. When we come back to the next section, we're going to run two commands that are going to create the service account and our cluster role binding. So quick pause, and I'll see you in just a minute. In the last section, we had a brief discussion about RBAC and security in a Kubernetes cluster. At the very end, we decided that for Tiller to work properly, we need to create it a service account and then create a cluster role binding and assign it to the service account we create. So here's what we're going to do. These are the two commands we have to execute. The first command is, well, you can read it. I'm not going to read it back to you. Essentially, the first command right here is going to create us a new service account with a name of Tiller. And it's going to create that service account in the namespace of kube system. Now, the only reason that this is being put in the kube system namespace is just to make sure that you and I do not accidentally mess around with it for some reason if we put it in some other namespace. After we create that service account, we'll then give it a cluster role binding. So this second command down here is going to create a cluster role binding with a name of Tiller cluster rule. The cluster role, or essentially the set of permissions that it's going to have, is going to be cluster admin. This is a preset cluster role, and it essentially means that anyone with the role of cluster admin can make as many changes as they want to just about anything across the entire cluster. After that, we then are going to assign this newly created cluster role binding to the service account called Tiller. Notice how the name over here, it has the namespace of kube system, which is the kube system namespace we assigned up here, and then a colon after it. So the name of the service account is Tiller, but it exists in the kube system namespace. All right, so that's the two commands we need to run. After we run those commands, we can then run that helm init command, which was what we were told to run after we had installed Helm originally. So this is going to be a fair amount of typing, so I do have to ask you to watch your typing here. You're going to get immediate feedback if you entered something incorrectly. It's going to tell you, hey, I've got no idea what you're doing here. But that's going to be the two commands we have to run, so let's get to it. I'm going to flip back over to Google Cloud, and I've got my shell open right here. So we'll first start off by creating our service account. I'll do kubectl create service account namespace kube system, and then the name of the account is going to be Tiller, like so. So I'll run that, and now my service account called Tiller has been created. So now we're going to create our cluster role binding and associate it with that Tiller account. So we'll do kubectl create cluster role binding. The name of this cluster role binding is going to be Tiller cluster rule. We're going to assign it a authorization rule set through -- cluster role equals cluster -admin. And then finally, we'll specify the service account that we want to associate this cluster role binding with. So I'll say -- service account equals kube system :Tiller. Now again, triple check the spelling on this command right here. It is awfully long, many places where you could very easily make a little typo. I'm going to very quickly enlarge this to be very large so you can read it very easily. There we go. Okay, so now I'm going to run that command, and I should see that the cluster role binding was successfully created. Great. All right, so now that we've done both those, I'm going to zoom back out here really quick. Now the last thing that we'll do is initialize Helm. Remember, it's that Helm init command that we were told to run after we went through that initialization process. If you wanted to, you could always look back at the installing Helm directions over here. And somewhere in here, I'm not going to find it because, again, this is just a huge document. It's all one file, so it's really hard to find stuff in here. But if you look through here, it's going to say somewhere, oh yeah, run Helm init after you do that in installation. So we're going to run Helm init, but we're going to add on a little option or two here. So we need to tell Helm exactly what service account Tiller should be assigned. So we're going to say, Helm, you're going to initialize yourself, and I want you to use the service account of Tiller that was just created. We're going to add on one additional flag to this thing, -- upgrade like so. The -- upgrade flag is just going to make sure that we're using the latest version of Helm. Okay, so we'll run that command, and then we'll see a little bit of a print up here, and that's pretty much it. So we now have Helm installed, and we can now use it to install brand new services such as Nginx and Gris inside of our application. So let's take a quick pause right now. When we come back to the next section, we're going to use Helm to install Nginx Ingress, and we are going to use Helm to install some stuff later on as well. So even though it might seem like, yeah, doing all this Helm stuff was a little bit overboard for what we're using it for, we are going to install stuff later on that we definitely need Helm for. So let's take a quick pause right here. When we come back to the next section, we'll continue with our Ingress setup. So I'll see you in just a minute. In the last section, we finished finally installing Helm onto our production Kubernetes cluster, multi-cluster. So now we're going to put Helm into practice, and we're going to use it to install the Nginx Ingress. Now, I still have the Nginx Ingress documentation up. Remember, you can get here at kubernetes.github.io/ingress nginx. You'll then find the deployment tab, and then down at the very bottom is the using Helm section. So you'll notice inside of here, it says if the Kubernetes cluster has RBAC installed, run this command right here. So essentially, all we got to do is copy this command, run it inside of our Cloud Shell, and we're good to go. So I'm going to copy this thing. I'll go back over to my shell. I'm going to paste it. And then I'll run that command. All right. And very quickly here, you're going to see that it gets resolved for us. So essentially what it did was create a full set of different objects behind the scenes. All the objects that were created are going to be very similar to what we had previously seen inside of this mandatory command YAML file right here. So we got a set of config maps, deployments, we got that default server, all that stuff we had spoken about previously. If you take a look at some of the output right here, you'll see that it gives us an example ingress. We are using an ingress that looks very similar to it. And you might also notice that we're seeing a little bit of a print up here of all the different resources that were created. So we got our load balancer, we got a cluster IP for the default backend. It looks like we got a deployment, we got a pod for the controller and for that default backend, and a couple of other stuff in here as well, such as a, hey, cluster role binding and a role binding. We now know what those are. So it looks like everything got set up correctly. So let's take a quick pause right here. When we come back to the next section, we're going to take a look at what happened in more detail inside of our cluster. So quick pause, and I'll see you in just a minute. In the last section, we used Helm to install Ingress Nginx inside of our project. Now that we've got that installed, I want you to refresh the page. So I'm going to refresh this entire thing. I'm going to say yes, go ahead and reload. And then I'm going to flip over to the Workloads tab over here. Remember, the Workloads tab is where we're going to eventually see a list of all of our deployments. So we can now very easily see that we have something here called the Ingress controller and our Ingress default backend. Remember, the Ingress controller is the pod that is, or in this case, the deployment that manages the pod that runs the actual controller that's going to read our Ingress config file and then set up Nginx appropriately. The default backend is, as it says, a default backend that has a series of health checks inside of it. If we were doing things really, really well, we would set up a certain number of routes inside of our Express API to associate the health of our cluster with our actual API, as opposed to this default backend. But in this case, using the default backend, totally fine. Now, the other thing I want to show you really quickly is the Services tab over here. Now, if you see something here that says load balancer and you see these two sets of numbers next to it, that's great. If you do not see two sets of numbers right here, then pause the video right now for like a couple minutes and try refreshing the page again in a couple minutes. After a little bit, you'll eventually see two sets of numbers appear right here. These two sets of numbers that you see are the actual IP addresses that we're going to eventually use to access our project. And so right now, as a matter of fact, you can click on the :80 address or the :80 port right there, and it'll open up a new tab at that IP address, and you'll see default backend 404 appear on the screen. This message right here is being created by, as you might guess, the default backend that was created for us. That's the purpose of the default backend. Not only does it provide a health check, it also provides a default 404 page that our users will go to if some route cannot be found inside of our application. All right, so eventually we're going to use this IP address right here to get access to our application later on. Now, before we continue, there's one other quick thing I want to show you. If you go to the navigation menu up here, we'll then scroll down a little bit. And inside of here, I always forget exactly where it is. Here we go. Network services under the networking section. So we're going to go to network services, and it'll dump us out on the load balancing tab. So this right here is the Google Cloud load balancer that was created for our cluster. You can take a look at the load balancer details. Essentially what it's saying right here is that the load balancer can be accessed at this IP address. This is the same IP we just went to a second ago. And the load balancer is governing access to this set of different instances. The set of instances right here that you see are different virtual machines. They represent the 3 nodes that belong to our Kubernetes cluster. So recall, we looked at this diagram a long time ago when we were talking about Ingress Nginx on Google Cloud. We had said that when we use Ingress Nginx, it's going to create a Google Cloud load balancer. So that's what you're looking at right here. This is the Google Cloud load balancer that is not at all native to Kubernetes. That load balancer is going to get traffic into our node, or the entire cluster in this case, and it's going to point traffic to the load balancer service, which is a Kubernetes service. It's a type of service. And that service is directing traffic to our Nginx ingress controller, which is eventually going to send traffic off to all of our different deployments. All right, so it's kind of fun to see this stuff all finally come together. Now, the very last thing we have to do is actually deploy our application, so we get all the rest of our infrastructure on here. So let's take a quick break. When we come back to the next section, we're going to finally deploy our app. So quick pause, and I'll see you in just a moment. In this section, we finally get to deploy our application after a ton of work. So we've made all of our changes to our K8s folder, all the config files in there. We've got our deploy sh file set up and the travis.yaml file set up. So to initiate our deployment, all we have to do is commit our work and then push it to our master branch on GitHub. Travis CLI is then going to automatically pick up our changes, run this travis.yaml file, and then hopefully eventually run the deploy.sh file as well. Now, before we do anything here, I want you to know that this entire setup process, even though I took really good notes on my side of things and I've gone through this process many times, entirely possible that I made a mistake. Entirely possible you made a mistake or a typo some way along the line. So if it looks like at any stage you get an error message, first thing to do is to go to the next section along with me. Maybe I got the same error message as well, and so we'll do a little bit of troubleshooting together. If that still doesn't help, then you can always go over to the QA and I'll do my best to help you understand exactly what went wrong. All right, so let's get to it. I'm going to first begin by going back over to my terminal inside the complex directory. I'll do a git status inside of here, and we'll verify that, yep, we've got a couple of different files changed. I'm going to add both those changes, and then I'll commit both them and say added deployment scripts. And then I'm going to do a git push origin master. All right, here's the moment of truth. So we'll run that command. It's going to push our changes up. And then we're going to flip over to our browser. We'll open up a new tab and go to travisci.org. And then once here, we'll go to our new multi-K8s project. Now, I want you to be aware that the first thing that can possibly go wrong is you might not see the build show up inside of here. If you do not see the build show up inside of here, then it very likely means that there is a typo somewhere inside of your travis.yaml file. If anything is wrong inside the travis.yaml file, you're never going to see the build show up here, and Travis is going to essentially just silently fail. And it's going to never pick up any change, and it's not going to give you any error message. Now, you'll notice that my build just got picked up, so if you wait a couple minutes and you still don't see anything show up here, then it very likely means that you have a typo inside this file. So if you have a typo inside of here, remember the entire source code for this entire course is in a Git repository, and it's linked towards the very start of the course. So you can always pull open. As a matter of fact, I got a link for it right here. Let's give it to you right away, make life easy. So the link to the repository with all the completed code is my GitHub ID Stephen Greider /dockercas. And so inside of here, you can find that complex directory, and it's not in here yet because I haven't updated this repo yet, but inside of the complex directory, you're going to see my .travis.yaml file. So you can always compare yours against mine. Now, if you do compare, do remember that you cannot just do a direct copy paste because there is some project specific information in here, like the project ID, the compute zone, the cluster name, and then some other differences inside of here like the Docker ID and some details around the OpenSSL command. But you can at least compare and contrast to make sure you don't have any obvious typos. All right, so we'll take a pause right here. It looks like I've already got a nice little error going on. So we're going to take a quick break. We're going to figure out what just went wrong, and we'll start fixing it. So quick pause, and I'll see you in just a minute. In the last section, I tried pushing my code, and I very quickly got an error message. And so looking at this error message, it says that the login process with Docker errored out. So this is really embarrassing because I made a huge deal about spelling Docker password and Docker username right here correctly. And I ended up managing to put 3 S's in the word password. So wow, that's embarrassing. Well, I'm going to fix that right there. I'm going to save my changes. I'll do a git add, a commit, and I'll do another push. Git push origin master. So again, I'll take a quick break. I'm going to let my build run again. And if there's another error, we'll take care of it in the next section. So quick pause, and I'll see you in just a minute. Wow, I'm actually kind of surprised everything worked correctly the second time through, at least the build did. Now remember, if you see any error message here, try flipping over to the QA, try comparing your code to mine on GitHub, because it's so incredibly likely that it's just a tiny typo. So at this point, it looks like the build successfully ran. All that really means is that we built our images, pushed them off to Docker Hub, and then ran some commands against kubectl on our production Kubernetes instance over here. Now, before we try to actually test out our site inside of Kubernetes or anything like that, I want to very quickly open up Docker Hub. I want to look at some of the different repos that we have inside of here. How about, say, multi-server? If I look at multi-server and then look at my tags, I'll see that both the latest tag and this new long tag right there were updated just 2 minutes ago. So that definitely means that I now have a permanent backup of my code as it was at this commit right here, or the image, I should say. And I also have a completely up-to-date tag of latest that new engineers can pull down in the future and know without a doubt that, yeah, they're running the latest version of this image. So that's definitely cool. Now, the next thing I want to do is go back over to my Kubernetes dashboard. So once over here, I'm going to refresh the page. And then I'll take a look at the workloads tab. So now over here, oh, this is pretty awesome. I see that I've got my client deployment, Postgres Redis server worker. All those deployments have been created. You can click into one of these deployments and you'll see all of the different pods that it manages, along with a couple of graphs detailing the runtime information about this deployment. So here's the managed pods right here. A little information about each one that's running, and of course we can click into each of those and see information about that individual pod as well. Now if I go over to services, I'm going to see a lot of information over here as well. So there's our set of cluster IPs. There's, say, the client cluster IP, all the others for all the other different sets of pods we have inside of our application. Now very interestingly, you'll see that we have an ingress service right here, and it has an endpoint of like */ and */ API. These two endpoints that you see right here are essentially routes, and those are the different routes that we had set up inside of our K8's ingress service.yaml file. So remember, inside of here, we set up the two paths. We have path of / and path of /API. So that's what these two endpoints right here are talking about. We still have the old load balancer. I shouldn't say old, it was just created, but it's the load balancer that we were talking about in the last section. So remember, the ingress right here is really just a config file. This config file is being shipped off to the ingress controller. The ingress controller is both making changes to Nginx and hosting Nginx simultaneously. Now, some other quick things I want to take a look at. If we look at configuration, we're going to have some config maps, which we haven't quite spoken about too much, but we do also see inside of here the PG password secret that we had previously created. We also see a service account that belongs to Nginx ingress. This service account right here was created by Tiller when it went through all that setup of Nginx ingress for us. The last thing I want to show you is storage tab over here. So you'll see that we have a persistent volume claim created. This is the database persistent volume claim that we had created to make sure that we had some permanent storage allocated to Postgres. So we can click into this. I don't know if it's going to show us the actual, well, here we go. So here's the volume right here. So we can click on this volume, and this is a volume that was created by that persistent volume claim. Now, if we want to, I'm pretty sure we could actually go up to our navigation menu up here and take a look at the storage for, is it data store? No, I forget exactly where it sits on here. Okay, maybe we'll come back to that, but I thought it would have been really nice to look at the persistent disk dashboard and see if that one was actually created over there, but I don't actually see anything on here related to the persistent data. Okay, so anyways, last thing we'll do, we'll go back over to services, and we're going to try visiting our IP address right here again. Now, if everything worked correctly, when we click on this, we should see our React project appear on the screen. I don't know what to expect here. I don't know if it's going to work, but whatever happens, we'll just deal with it accordingly. Okay, so I'm going to go to that address. I see the privacy error here, which is totally fine. Remember, this is something that we saw in our local environment as well. We are going to fix this up very quickly, so this is a very temporary thing. So I'll go to Advanced and then Proceed. Yeah, oh my gosh, I can barely believe it. It actually worked. Or at least I think it worked. Let's actually try entering a number here. I'll put in 4 and submit it, and then I'll refresh. Oh my, I can't believe it. It actually worked. Yes! Oh, I'm so happy. All right, my friends, there you are. There you have it, a Kubernetes cluster running in production. Now, we're not quite done. We have deployed this. We're just about there, but we still got this HTTPS error, so clearly we need to do a little bit work there. I also want to very quickly walk through the process of making a change to our source code and then redeploying all these changes and making sure that we can see the updates appear live at this address as well. So let's take a pause right now and tackle a couple extra steps in the next couple of videos. So I'll see you in just a minute. In the last section, we were able to verify that our deployment worked successfully, and so I now see my React application on the screen. Now, we still got a couple tasks ahead of us. The first thing I want to do is give you a really rock-solid workflow for making updates to your application after it's been deployed. Now, to be truthful, the process of making updates is going to be identical to the processes that we looked at before. No big changes whatsoever. But nonetheless, I want to walk you through these steps just to make sure that they are crystal clear. So here's the general idea of what we're going to do. We're going to check out a Git branch where we're going to make all of our changes. We'll then commit those changes, push those changes up to GitHub, and then create a PR to merge our branch into master. Remember, we generally treat master as like the perfect branch, and whatever code is on master should be the same code that is currently deployed. After we create the PR, we'll then wait for our tests to show up green after they've been ran by Travis CI. Remember, Travis CI is going to run your tests for every single branch that you push up and every different pull request that you create as well. But it's only going to attempt to deploy your code after it has been deployed into master. So we're then going to merge the PR, and then after Travis CI runs a second time with all of your merged changes, it's then going to deploy your code to the Kubernetes cluster, and we should then be able to see our changes appear on prod. So let's get to it. So the change we're going to make is going to be to our multi-client project again, just as it was previously. So I'm going to open up my client directory. I'll find the SRC folder. Oh, you know what? I completely forgot the first step. We want to check out a branch. Let's do that first. All right, so back inside of my terminal, I'll check out a branch with git checkout -b, and then the name of the branch. So let's call this like devel, short for develop. So we're going to make our changes to the devel branch, and then we'll eventually commit our changes and push those up. All right, so now we can go back over to our code editor. I'll find the client SRC folder, and then the app.js file. So you'll recall inside of here, we have that h1 tag that currently says fib calculator version 2. We're going to change that out, and we'll say version Kubernetes, just to make sure that it's really clear that, yeah, we made a change here, rather than trying to remember what version number we put in there. Now I'm going to save this file. So definitely saved it. Next up, I'm going to commit my changes and then push that branch up to GitHub. So back at my terminal, I'll do a git status and say, yep, I changed that file. I'll do a git add and a commit. And then I'll push it up to GitHub with git push origin devel. All right, so I've now successfully pushed those changes. So now I'm going to open up my project on GitHub and create a pull request to merge my code into the master branch. So I'll go to GitHub, my multi-K8s project. You'll notice that I see a little pop-up right here automatically that says compare and pull request. Just to make sure that you understand how to create a pull request without getting that nice little pop-up right there, we'll do it the more manual fashion. So I'll go to the pull request tab. I'll then click on New Pull Request, and then we want to take our compare of devel and attempt to merge it into master. Then I'll click on Create Pull Request right there. Now, if I want to, I can add in a message describing the changes. I could put in something like change the header of the app.js file, whatever you want to do. And then I'll create the pull request. Now, once the pull request has been created, we then wait on Travis CI to run our tests. Now you'll notice that there's two sets of waits right here from Travis CI. We get one from just pushing our code, and then a second change set from the pull request that we just created. If we wanted to, we could disable Travis CI from testing our code anytime we push code or push a branch, and we can make sure that it only tries to build our code when we create a PR, but that's kind of a personal preference. I leave it up to you on what you might want to do there. So I'm just gonna wait for a minute. I'm gonna let all this stuff run. When we come back to the next section, we're gonna verify that both these tests completed successfully, and then we'll start to merge the PR. So quick pause, and I'll see you in just a minute. After a couple minutes, it looks like both those tests have successfully ran. So now I'm going to merge the pull request. After I merge the pull request, I'll then wait, and eventually all my changes will be automatically deployed to our Kubernetes cluster. The old set of pods will be taken down to by our deployment, and the new version of our image will be deployed. So all we have to do to make that happen is click on the merge pull request button right here. So I'm going to pull on that, or click on that right now, and then confirm the merge. That's merge this. If I want to, I can delete the branch or just leave it around. Doesn't really matter. Again, that's kind of a personal preference thing. So now after a minute or two, we're going to eventually see Travis CI light up again, and it's going to attempt to run our tests for a third time with the newly changed master branch. So I'm going to sit around and just wait for that to happen over a couple minutes. After those things run, we should then be able to flip over to our React application and see the new version over here. So let's take a quick pause, and I'll see you in a couple minutes. In the last section, we merged that pull request. Travis CI then pulled down our code for a third time and ran it, and because this time it was being executed on the master branch, it then deployed all of our changes after building the images. So now I'm able to go back over to our IP address, which remember you can get from the Services tab on our Kubernetes dashboard. So there's the IP address right there. And then once I go there, I can refresh the page, and I see version Kubernetes appear. Awesome. Well, my friends, it's been a long time, but that's pretty much it. We've got our Kubernetes cluster put together. Now, of course, there's still one little issue here, the issue of that HTTPS stuff. So I'm going to be honest with you, before we dive into any of the HTTPS stuff, fixing this right here is like just a real not fun thing. I'm going to be honest with you. So if you want to, if you're kind of thinking, all right, I understand Kubernetes, like this stuff's going pretty well, and you feel like you got your hand on it, and you feel like you understand this, I'm going to tell you, just stop now. Say, that's it. That's a great course. I had fun, but that's it. I don't really want any more pain. If you really want to, we're going to walk through the process of fixing up this thing right here, but I got to tell you, it is just a real pain in the rear. In addition, it's also going to require you to buy a domain name, which is going to cost about $10 US. So if you're kind of done with this stuff, you don't feel like going through it anymore, totally fine. I understand. I hope you enjoyed the course. Otherwise, stick around. In the next section, we're going to figure out how to set up HTTPS on our Kubernetes cluster. So quick pause, and I'll see you in just a minute. All right, my friends, if you are still here, it means that you want to figure out how to set up HTTPS support on your Kubernetes cluster. Now, the first thing I want to mention to you, and I want to make sure this is really clear, is that in order to set this stuff up, you are going to have to purchase a domain name, which is about $10 US, although sometimes you can find ones for a little bit cheaper than that. So this is a required step. You have to have a domain name, either one already purchased, or you have to buy one to use with your cluster. Now, the second thing I want to mention is that you and I are going to go through the process of setting up HTTPS, but we're not going to talk very much about TLS or HTTPS or certificates or anything like that. There's a ton of resources out there online already for you to understand exactly what HTTPS is doing for us and the benefit of applying it to any given web application. So with that in mind, let's talk about the overall process of how all this stuff is going to work. All right. So we're going to set up a little bit of interaction between our Kubernetes cluster and a certificate authority called Let's Encrypt. I suspect you've probably heard of Let's Encrypt. If you haven't before, essentially it's a service that allows us to get free certificates. All we have to do is set up a little bit of communication between our Kubernetes cluster and a Let's Encrypt service. So here's the sequence of actions that are going to be going on behind the scenes. You and I are not going to actually see these steps occur. We're going to kind of peripherally see them occur, but essentially what we're going to be doing for setup is creating some infrastructure to allow these steps to happen. But again, you and I aren't going to very directly see these things occur. So the first thing that's going to happen is our Kubernetes cluster is going to issue a request to Let's Encrypt, and it's going to say, hey, I own a domain called multik8s.com, and I need a certificate from you, Let's Encrypt, that says that I do in fact own that domain. And once we get that certificate, we can then use it to set up HTTPS that is going to be widely supported or recognized by any given browser, such as Chrome, Internet Explorer, whatever it might be. In response, Let's Encrypt is going to immediate reply and say, you own multik8s.com? I don't believe that. I don't believe it for a second. But I'll tell you what, I'll give you the benefit of the doubt. If you, Kubernetes cluster, really do own the domain multik8s.com, I'm going to make a request to multik8s.com /well-known/random string of numbers right here. If you really own that domain, then you will reply with some information that I expect to hear from you. So essentially what's going on right here is Let's Encrypt wants to make sure that you and I really truly own this domain. So it's going to tell us that it's going to make a request to some route, like this right here. And if we truly own this domain, you and I are going to set up a route handler that's going to reply on specifically this route right here with some information that is provided to us by Let's Encrypt. So that is something that is very challenging for us to fake. If we said that we own something like, google.com, and Let's Encrypt replied in the same fashion and said, okay, well, if you really own google.com, I'm going to make a request to google.com / this random route right here. Chances are you and I are not going to be able to manipulate Google's infrastructure to get the appropriate response to that route. So that's how this authentication process is essentially going to go down. Let's Encrypt is then going to make a request to that route. And then as long as our Kubernetes cluster responds with the appropriate data, Let's Encrypt is going to say, oh, okay, you know what? I guess you do own this domain. So I'll tell you what, you check out, you own the domain, so I'm going to give you a certificate that's going to be good for 90 days. And after that period, or when that time is about to elapse, you're going to have to go through the same process all over again. So in some number of days, you're going to have to come back to me and ask for another certificate and claim that you own the domain multik8s.com. So as long as we set up some infrastructure to handle this, we'll get our certificate and we'll be good to go. Now, to give you a little bit more behind the scenes here of what you and I actually have to do. You and I are not going to set up any route handlers to facilitate this process. You and I are not going to be making any request over to Let's Encrypt. We are not going to do any of that stuff whatsoever. Instead, we're going to set up another little plugin through the use of Helm. Remember, we installed Helm just a little bit ago. We're going to use Helm to install something into our cluster that's going to automatically facilitate this process for us. So we're going to install something into our cluster that's going to automatically reach out to Let's Encrypt. It's going to say that we own some particular domain. It's going to automatically set up a route handler to respond on this route. It's going to then automatically get a certificate back from Let's Encrypt. It's going to save it into a secret and make it available to the rest of our application. And then after some amount of time elapses and the add-on decides that it's time to renew the certificate, it's going to automatically go through this process again. So the challenge for you and me is not setting up like this stuff right here. It's setting up the infrastructure to do this stuff for us automatically. That's the challenge. That's what we need to do. So with that in mind, let's take a quick pause right now. We're going to come back to the next section and we're going to start going through this setup, starting first with purchasing a domain. So quick. In this section, we're going to go through the process of purchasing a domain name that we're going to eventually use for our HTTPS setup. Now, as I said several times so far, you have to have a domain name to go through the setup process. There's many different websites that you can purchase a domain name from, but we're going to be getting one from domains.google.com, which is Google's domain service. If you choose to use a different domain registrar, do note that we're going to have to do some setup on the domain registrar page. And so if you use a different setup, or excuse me, a different provider such as Namecheap or GoDaddy or whatever it might be, the setup process is going to be different, and it's going to be on you, to be honest, how to change the setup. Because I don't really know how to do domain setup or manipulation of records on, say, GoDaddy. So if you're not going to use Google Domain Registrar, kind of up to you to do a little bit of configuration. All right, so let's get to it. I'm going to go to domains.google.com inside of a new browser tab. Once here, you'll notice that I personally have actually already purchased a domain for use with our product, but I'm going to walk through the process of purchasing a new one. So I'll find the Search Domains tab here on the left-hand side. And then we can search for any domain that you might want. So it's totally up to you, no requirements on the name or the TLD that it uses. So we could do something like, I don't know, just total gibberish if you want to pay like no money. I mean, even these are $12 a year if you want total gibberish, but hey, it's totally up to you. So you can pick out a domain name that you want. You can then add it to your cart and then go to your cart and check out. So here's that domain right here. Now, one thing to triple check, you'll want to turn off auto renew unless this is a domain that you want to hold on to. Now, once you find your domain and decide to purchase it, you can go to checkout and purchase the domain. After a little bit, you'll eventually see the domain appear on your domain dashboard back at domains.google.com. So for example, here's mine right here. Now, once you purchase the domain, we are going to go through just a tiny bit of setup, the setup that I just mentioned a second ago. So let's take a quick pause. We'll come back to the next section, and we're going to start to configure the domain that you just purchased. Now that you've got your domain purchased, we're going to do a little bit of setup and make sure that it points to our Kubernetes cluster IP. Specifically, the IP address that you can find by going back to your Kubernetes cluster dashboard, going to Services, and then finding the ingress controller right here. So that's the IP address that we're going to make use of, and we're going to make sure that going to our domain name that we just purchased is going to point at that IP address. Now to set this up, I'm going to find the DNS settings for the domain that I just purchased. So I'll click on DNS, and then we'll scroll to the bottom of this page. So I'm going to go down to the bottom, and I'll find Custom Resource Records. We're going to set up 2 separate records in total. The first one is going to make sure that anytime that someone goes to my domain name of multi-k or k8multi.com, they get forwarded to the IP address that is specified right here. The second rule that I'm going to set up is going to make sure that if someone goes to www.k8-multi.com, they go to the same IP address as well. Remember, there is a difference between, say, www.google.com and just google.com. And we need to make sure that we handle both cases appropriately. All right, so under Custom Resource Records, I'm going to put a @ symbol in here like so. I'm then going to make sure that the A record type is selected. I'll put in a 1 hour time to live, which is essentially a description of how long it's going to take for this new record to kick into effect. And then we'll enter in an IP address over here. The IP address is going to be the IP that was assigned to your load balancer. And again, you can find this by going to the Google Cloud Platform and looking at the Services tab. So my IP address is 35224.4071. We do not need to add on the port at the end. We need just the IP address by itself. So I'll put in the IP like so. Now again, notice that there is no :AD on here or anything like that. It's just the IP address. Okay, so I'm going to add that record. And then we'll create one other record as well. I'm going to change the type in this dropdown to a CNAME record. I'll put in www on the left-hand side over here. We'll again do a 1 hour time to live. And then for the domain name, we're going to make sure that if someone visits the www address, it's going to send them to k8-multi.com. And of course, this will be your particular domain name, not mine. So once we get that in there, I'll then click on Add. And that's pretty much it. We're good to go. Now you'll notice that on the right-hand side, there's a little dot on there that got inserted. That's totally fine. You can leave it in there, no issue whatsoever. All right, so we've now set up our domain name and we've pointed it to our IP address that has our load balancer. After some amount of time, we're going to eventually be able to go to the domain that you just purchased and be able to access our application. Now you are going to be able to do that even before we set up all this HTTPS stuff. You can access the domain appropriately without going through all the HTTPS setup, but of course you are still going to see that red error not secure message until we go through that setup. All right, so let's take a quick pause right here. We'll come back to the next section, and we're going to continue with starting to set up our Kubernetes cluster to obtain a TLS certificate. So quick pause, and I'll see you in just a minute. Now that we've got our domain purchased and configured, we're going to start to create all the infrastructure that's going to facilitate the automatic communication between our cluster and Let's Encrypt to eventually obtain a TLS certificate. Now, the project that we're going to be using to do this is called Cert Manager. That's the name of the project. The homepage for this project is at github.com/jetstack cert manager. We're going to go there right now and follow their documentation to install Cert Manager into our cluster. So inside of a new browser tab, I'll go to github.com/jetstack cert manager. And then once here, I'll scroll down a little bit and find the documentation section. So here's the link to the documentation right here. Once here, I can find the Getting Started link on the left-hand side. And then I'll find Installing Cert Manager with Helm. So I'll click on that, and there we go. That's the command we need to run. Now, we haven't really said what Cert Manager is doing for us just yet. We are going to have a discussion on what Cert Manager is doing and how we actually integrate it into our project. But for right now, I just want to get it installed. So I'm going to copy this link right here. I'll go back over to my Kubernetes dashboard on Google Cloud, where I've still got my Cloud shell open. So I'm going to paste in that command and run it. That's going to download a bunch of config files and install them inside of our Kubernetes cluster as a couple of different new objects. Now you'll see that there's a little bit of information in here. It looks like it created a new pod for us, a new deployment, new cluster roles, and some other stuff in here like a service manager and whatnot. So this is looking pretty good. Everything is definitely set up correctly. So let's take a quick pause right here. When we come back to the next section, we're going to start talking about exactly what Cert Manager is doing for us and how we integrate it into our project. So quick break, and I'll see you in just a minute. In the last section, we installed Cert Manager into our Kubernetes cluster. We're now going to briefly discuss exactly what we have to create to integrate Cert Manager into our project and get it working the way we expect. All right, so a couple diagrams here. All right, here we go. So in this diagram, at the very center is Cert Manager. As you just saw, when we installed it, it created a deployment, which in turn created a pod. There's also a service account and a cluster role binding in there as well, which essentially gave that pod the ability to manipulate our cluster and create different resources inside of it. So Cert Manager by itself, you can really just think of as essentially being a pod that is going to reach out to our cluster and kind of mess around with things. And then at some point in time, it's going to set up a route handler to respond to the Let's Encrypt verification request. Now, in order to get Cert Manager working the way that it expects, there are two different objects that we have to create with two different config files inside of our project. So these are two types of objects that we're going to create in the same way that we've created many other objects before. We'll talk about the issuer first over here on the right-hand side. The issuer is going to be a config file that's going to tell the Cert Manager how to reach out to a certificate authority and obtain a certificate. So in our case, we are using a certificate authority, or essentially an entity who issues certificates of Let's Encrypt. Let's Encrypt publishes some public APIs and API addresses to access those out for you to read very easily. So we're going to create this issuer object that says essentially we want to use Let's Encrypt, and here's the address to the API to use to initiate this entire exchange process. So that's the purpose of the issuer. It's just telling Cert Manager where to go to attempt to initiate this verification process. The reason that we create this in an object is that Cert Manager is set up to allow you to define several different issuers. And even if you're using Let's Encrypt, you might want to have more than one issuer. For example, with Let's Encrypt, you get the ability to connect to a staging server, or essentially kind of a practice version of Let's Encrypt. So for example, if you're not sure that this entire flow is going to work the way that you expect, you would access the staging version, or essentially the practice version of Let's Encrypt, before eventually moving over to the real production version of Let's Encrypt when you eventually want to get your certificate. So that's why we were able to create multiple issuers. Now for us, I'm pretty confident that everything's going to work correctly the first time, maybe. So we're not going to create multiple issuers. We're going to create just the one, and we're going to go directly to Let's Encrypt production the first time around. Honestly, if you use staging, that staging workaround with Nginx ingress, like we are, life actually gets more confusing than you would think. So it's kind of better to just access the production version of Let's Encrypt the first time around, rather than trying to use the staging version and then flip over to production later on. Now, the other object that we need to create, again with a config file, is going to be something called a certificate. The certificate is going to have some information that details the exact nature of the certificate that we want to obtain. So whenever you get a TLS certificate, such as the one I'm using or the one that draw.io uses, which is this diagramming tool that I am using right now, if you look at the certificate right here, you'll see that it has some information in the details section, like who draw.io is, so it looks like it's issued by Cloudflare. There's some other information on here about location and issued by blah, blah, blah. Essentially, there's a lot of information tied to the certificate. So the purpose of this certificate object file, or the config file, is to say, here is the domain name that we want to use for the certificate. It'll also have some information about maybe subdomains that we want to register under the certificate as well. And just in general, it's going to describe the nature of the certificate that we want to get. The certificate is also going to define a Kubernetes secret. Remember, we use a secret to store secret information. Now, the certificate gets a little bit relevant later on, so let's continue walking through this flow. So we're going to create the certificate and the issuer, and then we're going to not necessarily feed them into the cert manager. The cert manager is actually going to automatically see that we have created a certificate and an issuer. Once it sees that both of these have been created, it's then going to initiate that exchange process with Let's Encrypt. Let's Encrypt is going to eventually issue a certificate. So once that cert manager gets the certificate from Let's Encrypt, it then needs to store it somewhere inside of our Kubernetes cluster. And that's the purpose of the secret that got created over here by the certificate. So just to be clear, you and I are not going to create the secret in the same way that we did previously. So we're not going to run kubectl create secret or anything like that. We're going to instead put an entry into the certificate configuration file that says, hey, certificate, when you get created, you should make a secret called something, something, something. And the secret will be created for us automatically. Now, once we get that certificate and store it inside the secret, the last thing we'll have to do is reconfigure our Nginx ingress. So we're going to make a little change to that configuration file for our ingress, and we're going to tell it, hey, you should now start serving up HTTPS traffic. And by the way, here is a secret that is holding the certificate that you need to use. So that's pretty much the overview of what we have to do. We have to create the certificate, the issuer, and then we have to do a little bit of a reconfiguration on our Nginx ingress. So let's take a quick pause right here. When we come back in the next section, we'll get started by working on our issuer config file to start. So quick pause and I'll see you in just a minute. In this section, we're going to start putting together our config for the issuer object. This is going to be another configuration file, very much like all the others we have previously put together. So inside of my code editor, I'll find my K8s directory, and inside there, I'm going to make a new file called issuer.yaml. Again, the purpose of the issuer file is to describe to our cert manager exactly where it should go in attempt to get a certificate. Now, just like many other config files we put together, we're going to have an API version. We're going to specify an API version here, very dissimilar to any other that we've put together so far. We'll say certmanager.k8s.io/v1 alpha 1. Now, the reason for this very different API version right here, remember that the API version is essentially specifying a bucket of different object types that we can pull from. We've said that we're going to make an object of type issuer, and that is definitely not an object that is included in Kubernetes by default. It is something that is defined specifically by the cert manager that we just installed. So for the API version, we're saying reach into the cert manager bucket of objects. We want to be able to create a issuer type object. So on the next line, we'll define our kind of object, which is going to be a cluster issuer. We'll then put down our metadata tag and give this a name. We're going to name it after the source for the issuer. So the purpose of this issuer is to tell our cert manager to reach out to Let's Encrypt, and specifically the production version of Let's Encrypt. So we're going to give this a name of Let's Encrypt-prod, like so. After that, we'll put down a spec. This is going to have an entry of Acme. We'll then specify the server that cert manager should reach out to when it tries to establish this verification process. So this is essentially a link to the Let's Encrypt API that's going to be used for setting up all this different communication back and forth. So this is going to be a hard-coded URL right here. we're going to do HTTPS, notice the S on there, acme-vo2.api.let'sencrypt.org/directory, like so. Now after that, we're going to put in our personal email address. Now the email is not actually used as part of this verification or anything like that. Let's Encrypt says that they have to have your email on hand just for whatever purposes they decide. So we're not going to actually get any emails or anything like that or have to respond to anything. Nonetheless, I still do recommend that you put in your real email address. So for my email, inside of a string, I'll put my email, like so. Next up, we're going to define something called a private key secret ref. And we'll give it a value of name, let's encrypt prod. All right, so the private key secret ref right here is not at all connected to the secret that is generated as a part of the certificate. It turns out that behind the scenes, when your Kubernetes cluster is going to eventually communicate with Let's Encrypt, during this process, at some stage, Let's Encrypt sends over a little secret key that is tied to essentially your record with Let's Encrypt. And it actually comes into play as a part of this verification process right here. It's actually used to essentially decide exactly how to respond when Let's Encrypt tries to access this randomly generated URL. It's this little key that gets sent back to us and stored inside of the secret key ref is not actually something we ever have to use. So essentially we just kind of throw it on here and forget about it. Now the last option we'll put on is HTTP 01, and we're going to put a set of curly braces like so. Now this probably looks like a real weird option right here. So all this option is doing is saying we want to use this HTTP process of obtaining a certificate. We want to reach out to Let's Encrypt and say, hey, I want a certificate. Let's Encrypt says, okay, respond on this route, and then we eventually do. That's all this little configuration line right here is doing. There's actually another different way of obtaining a certificate or going through this verification process that is a little bit different than the HTTP one that we're putting together right now. But without a doubt, setting up the HTTP version is a lot easier than the other DNS option that is available. All right, so that's pretty much it. That's all we have to put together inside of our issuer.yaml file. So I'm going to save this file, and then I'll close it out. We're going to take a little pause, and then in the next section, we're going to start putting together our config file for our certificate as well. So quick break, and I'll see you in just a minute. In this section, we're going to start putting together our certificate file. Again, this is going to be a config file that's going to describe some details around the certificate that we are trying to obtain. So back inside of my code editor, I'm going to create a new config file inside the K8s directory called certificate.yaml. Then inside of here, we'll put together a little bit of config. As usual, looks very similar to a lot of the other config files we've put together. We'll start off with an API version, again, of certmanager.k8s.io/v1 alpha 1. The kind is going to be a certificate. And our metadata is going to have a name. And I'll use my domain name in here just to make sure that's really clear what this certificate is for. So my domain was K8s-multi-com, and I'll put on TLS on here just to indicate that this is a TLS certificate. All right, after that, we'll put down our spec. We're going to provide a secret name of K8s-multi.com. You can replace this with whatever your domain name is, both for the name up here and for the secret name down here as well. The secret name right here is specifying where our certificate should be stored after it's obtained by Cert Manager. So this is this little secret that is created as a part of the certificate. Again, we do not have to create this secret ahead of time. It will be automatically created for us by Cert Manager once it obtains the secret. After that, we'll define a issuer ref. The issuer ref is a reference to the issuer that we set up and want to use in order to obtain the certificate. So for us, our certificate issuer is going to be Let's Encrypt prod. So for issuer ref, I'll provide a name of Let's Encrypt prod, and then we'll also designate a kind on here as well. The kind is just indicating the type of issuer that's being used. Our type of issuer is a cluster issuer. So my kind back over here will be cluster issuer. Okay, so that's the boring part. Now here comes the more interesting stuff. We're going to put down a common name. My common name is going to be k8smulti.com. So for you, it's going to be just your domain name with the TLD on there as well. The common name is what's going to be put on the certificate in bold letters saying this certificate is good for any address of k8smulti.com or whatever your domain name is. So again, if you say go back over to any existing web page that you might have access to and look at its certificate, and then look at the details on right there underneath details, it lists out a common name, in this case of draw.io. And so the common name in this case is saying, yep, this is what the certificate is good for. Now after that, we'll provide DNS names. And we're going to put down two separate entries here. The first entry is going to be your domain name. And then the second one will be the www version. Like so. And remember, this is an array, so get the 2 dashes on there and make sure you've got the correct indentation as well. Now we're gonna not talk about DNS names quite yet. We're gonna fill out just a couple more lines and we'll talk about exactly what DNS names means. All right, so after that, we'll put down Acme. We'll put down config. I'm gonna put a dash in here and then say HTTP 01, a colon, and then indented inside there, I'll say ingress class is Nginx. And then underneath that, we'll put domains. And I'll put down www. Actually, let's do it in order, same order as DNS. So I'll put domains, a dash, because this is an array, and I'll do k8smulti.com. So your domain in this case, of course, and www.yourdomain again. So for me, k8smulti.com, like so. All right, so what's going on here? We've got DNS names out here and domain names down here as well. So what's going on is essentially DNS names is the list of all the different domains that should be associated with the certificate. In other words, when we get back a certificate, it's going to be good for a domain name of k8smulti.com, and it's also going to be good for a domain name of www.k8smulti.com. So if a user goes to either of these addresses, our certificate is going to cover it. Now down here, we list out the same 2 domains again. These are the different domains that the verification process, so this entire back and forth flow, is going to attempt to access to make sure that we actually have access to the listed domain names. So it might seem like we are just repeating the same thing twice. Yeah, we definitely are, but that's how the authors put this thing together, so we get the 2 separate listings. Okay, so that's pretty much it for this certificate config file. So I'm going to make sure that I save this as well. Now we're going to take a quick break, and when we come back to the next section, we'll do one last little piece of configuration, and then we're going to deploy this thing and test it out in production. So quick pause, and I'll see you in just a minute. In the last section, we put together our certificate.yaml file. Now at the end of this section, I said there was one last piece of configuration we have to do. It was a little bit off base there. We do have to do one last piece of configuration to our ingress defined inside of our ingress service.yaml file, but we actually only do that last piece of configuration after we have successfully retrieved our certificate. So the general flow here is that we get our issuer, we get our certificate, we deploy that. Cert Manager is going to go through this back and forth process and get our certificate. And then only once we have it, and we have it in hand, stored inside of a secret inside of our cluster, are we going to go back to our ingress service and tell it to update itself to use this new certificate. So in other words, we're now at the point where we need to redeploy our application so that the issuer and the certificate files are created as objects inside of our cluster. Once we do that deployment, the Cert Manager that we already installed using Helm is going to see the issuer and certificate and automatically go through this process of reaching out to Let's Encrypt. So to deploy our application, I'm going to flip back over to my terminal. Now I've been making all these changes on the devel branch. To be honest, I don't really want to have to go through the process of creating a pull request and all that stuff again and have to wait for multiple runs of our Travis CI server. So instead, I'm just going to change back over to my master branch and commit all of the work over on that branch and then push it directly to master on GitHub. So to get started, I'm going to do a git checkout master. I'll then verify that I see all the changes that I just made to my project. So there's the 2 files we just added. I'm going to do a git add in a commit. So I'll say added certificate and issuer. And then I'm going to do a git push origin master. Oops, it looks like I've made a couple changes to my project up on GitHub. My mistake, so I need to just pull my changes down. To do so, I'll do a git pull origin master, and then it's going to automatically create a merge request here. So I'll do a right quit like so. So now I can do a git push origin master again, and there we go, all good to go. All right, so as usual, this is going to be picked up by Travis CI. It's going to run our tests, and then it's going to attempt to apply all the different config files in the K8s directory. Since we just created certificate.yaml and issuer.yaml, they will both be created automatically by our kubectl command running over on the Travis CI instance. That will then update our cluster, creating those two objects, and then we should see the cluster essentially start to spring to life with the two new resources, either inside of our workload section right here or the configuration section over here. And honestly, we should actually eventually see the configuration section get that new certificate that we just asked to be created and stored. All right, so we're going to take a pause right here. I'm going to let Travis CI kick in and do its little thing. And then I'm just going to sit around for about 5 or 10 minutes and allow time for Cert Manager to reach out and get that certificate. So in total, I'm going to wait maybe 10-15 minutes or so. So we'll take a quick break and see you in just a little bit. All right, my friends, looks like Travis CI has successfully ran all of my tests and made changes to my production Kubernetes instance. I'm now going to flip over to my Kubernetes dashboard. Now, as a quick reminder, I've waited a couple of minutes here, or at least long enough where I feel like, yeah, everything has probably been updated successfully. We can very easily check to make sure that everything was done correctly by running a couple of commands inside of our Cloud Console. So the first thing we can do is try to get our certificate object that we had created. And when I say get, I mean run the kubectl get command. So inside my Cloud Console, I'll do a kubectl get certificates. And this will print out all the different objects of type certificate that exist inside of our cluster. So I see right there, there is the certificate object they had created. It was created 2 minutes ago. Now, to really make sure that this thing works successfully, I can then do a kubectl describe certificates. And this will print out some information about the certificate object. In particular, it's going to have a little bit of log information that describes this back and forth project with, or excuse me, back and forth process with Let's Encrypt. All right, so I'll do kubectl describe certificates, and I'll see a bunch of information print out here. Now, I want you to know you might see something in here around like message, and it might say like validation failed. You also might see status false and type validate failed. So if you see these like validation failed messages, don't panic just yet. You can essentially ignore these last couple of keys inside of here. What's really important is the list of events that gets printed up at the very bottom. So notice how for my events, I see issues or see messages of created new Acme order attempting validation. I then see that the domain of www.k8smulti was verified successfully, and I see the same thing for k8smulti.com as well. I then had the certificate issued, we obtained the certificate, and then issued successfully. So the next thing I can do to make sure that this all worked correctly is check out the secret that we had said that the certificate should be stored inside of. Inside my certificate.yaml file, remember we provided a secret name of k8smulti.com, or at least that's what it was for me. So I should now be able to look at a list of all of my different secrets and verify that there is a secret with this name. I won't necessarily be able to look at the contents of the secret, maybe might not want to, but I can at least verify that yes, the secret was created and probably contains the TLS certificate. So to do so, back inside of my Cloud Shell over here, I'll do a clear, and then kubectl get secrets. And right here, I see k8smulti.com. All right, I see data 2, which probably represents the public and private keys that make up the certificate. So that's pretty much it. It looks like we have successfully set up the process of reaching out to, there it is, Let's Encrypt, and we've successfully gotten this response back from them that told us to set up a route. They pinged our cluster. That request was automatically responded to through the Cert Manager tool, and in response, we got a certificate that's going to be good for some amount of time. So now in theory, when that certificate is about to expire, Cert Manager should wake back up and attempt to go through this process all over again. All right, so now the very last thing we have to do is make sure that our Nginx ingress is aware that we have a TLS certificate and start using it for serving up traffic. So let's take a quick pause and we'll get around to that in the next section. The last thing we have to do to set up HTTPS traffic with our cluster is to reconfigure our Nginx ingress. Inside my code editor, I'm going to find the ingress service config file. So we're going to make a couple changes to this file just to tell it, yep, here's how things are working now. You are now serving up HTTPS traffic. The first change that we're going to make is going to be to update the annotation section. Underneath the existing two annotations, we're going to add on a rule of certmanager.k8s.io/cluster issuer is let's encrypt prod. So this little piece of configuration right here is just going to inform our ingress service that we are going to be making use of a let's encrypt certificate. And I'm looking at this now and I notice I just made a small typo. It should be let's encrypt -prod, like so. Okay, so again, this is going to make a little change to the Nginx server, and it's going to essentially tell it, hey, you should be expecting to get a certificate from this issuer, the issuer designated by let's encrypt prod. The next thing that we're going to do is we're going to make sure that the Nginx server always forces users to make use of HTTPS traffic. So we do not want any users accidentally going to the HTTP version of our website because that's not a secure connection. So to make sure that our users always get redirected over, we're going to add on another annotation here of nginx.ingress.io/SSL redirect is going to be true. And remember, true goes into a string because the value true is interpreted differently inside of a YAML file. So like I said, this is going to reconfigure Nginx and tell it to always make sure that if someone is trying to access our service, they must be using a HTTPS connection. So now the next thing we're going to do is to update our spec section down here and tell Nginx that it should be serving up HTTPS traffic and also tell it where it can get our certificate from. So to set up the initial HTTPS side of things, under spec, I'm going to add on a TLS section. I'll then put down a dash and I'll say hosts, and then another dash, because this is going to be a list of different hosts that users can connect on. And I'll put in k8smulti.com and www.k8smulti.com. And then on the same level as the host indentation, I'll put down a secret name. Notice how this does not have a dash in front of it. And then the name that we're going to put in here is the name of the secret that we had stored our certificate in. So to get that, I'm going to go back over to my certificate.yaml file. Here's the secret name that I used, k8s-multi.com. So back over here, I'll do k8s-multi.com, like so. Oh, it looks like I might have made a little typo there. So to correctly create the YAML array, looks like we wanted 2 indentations off of hosts. I apologize for that. All right, so again, this is going to tell Nginx that we want to serve up HTTPS traffic. We want it to be served up on these 2 different host names, and the certificate or the secret that holds the certificate to allow for HTTPS traffic is served or stored inside the secret of name k8smulti.com. Now the last thing we have to do is a little bit of a reconfiguration of our rules down here. Now I'm going to tell you right now that the little reconfiguration we're going to do is going to be a little bit over the top. Unfortunately, this is stuff that just has to be done this way because of the way that the Nginx ingress is currently written. So hopefully at some point in the future, we don't have to do this little reformatting that you're going to see, but at least for right now, it's just what we have to do. Okay, so on the rules section, I'm going to put a new line right above HTTP like so, and I'll designate a host of k8s-multi.com. So this is essentially saying that if someone comes to k8smulti.com, here is the set of rules that we want to be applied to that request. Now the part that's funky about this is that if a user comes to www.k8smulti.com, the entire rule set that we have right here this does not apply to someone coming to www. www is recognized as a separate host from the host name that we listed right here of k8smulti.com. So essentially, if someone comes in on this address, great, we've got a set of rules to be applied to. However, if someone comes in on this address, the same exact rule sets do not apply. So the part about this that is funky is that we essentially have to take this entire block right here and copy paste it down. We have to duplicate this entire block, and then on the second block, we're going to change the host to be www.k8s. So I'm going to do my copy, and then I'll paste. So here's the second block right here. I've got block 1, block 2, and the only thing we need to change in block 2 is to add on the www like so. Again, this is a really unfortunate part of Nginx ingress. You can look on the GitHub issues board and see a couple threads around this issue because right now, essentially, yeah, we got to list out the 2 separate hosts, and it's just a little bit, it doesn't feel very dry, I guess is what I'm saying, right? Don't repeat yourself. Well, we're definitely repeating the heck out of ourselves here. All right, so that's pretty much it. So let's now review what's going to happen. We made changes to the ingress service config file. So when we deploy this thing or apply it to our cluster, the ingress controller is going to see a change to our ingress resource. It's then going to create a new Nginx config file out of everything we put inside of here, and then reload the Nginx pod with this new config that should start serving up HTTPS traffic. So last thing we have to do is save the file. I'll go back over to my terminal. I'll do a git add. I'll do a commit, and I'll say updated ingress. And then I'll push to origin master again. All right, that's pretty much it. So now again, we're going to sit around and wait for a couple minutes. After this deploy goes in, we should then eventually be able to test out our browser going to HTTPS your domain name, and we should see our page load without any error message like this right here. So let's take a quick pause and we'll continue in just a minute. It looks like my Travis CI build has successfully passed, so in theory, all the changes that we just made to that ingress config file have now been placed on our Kubernetes cluster. I'm going to go back over to my Kubernetes dashboard and then refresh the page. Now once I refresh the page, I'm then going to go to the Services tab. And then on here, you might notice that on the ingress service, we see a couple of different endpoints that exist. So each of these different endpoints now represent the different routes that our ingress Nginx controller is going to handle. As a quick test, I'm going to try visiting the first link right here that's going to take me to k8s-multi.com. And when I go there, sure enough, I see our updated version Kubernetes, and I've got that nice little green HTTPS on the left-hand side. So it definitely looks like this worked successfully. But we don't really know for sure until we do a better test. For example, what happens if I try to go to www.k8smulti.com? If I go there, I still see the same page. Awesome, that's exactly what we expect. Now, what if I go to, say, HTTP? If I go to HTTP, I really want to make sure that this thing gets automatically redirected over to HTTPS, because I don't want my users visiting the HTTP version of my page. So I'll try going there, I get redirected, and then one last combination, if I go to HTTP, without the www, I get the redirect over to HTTPS as well. So that's pretty much it. We did it. We set up HTTPS on a Kubernetes cluster. Now, I know like a dozen videos ago, I said, oh yeah, this is really hard. And maybe it didn't seem like it was super hard. I guess in retrospect, it wasn't the worst thing in the world. But trust me, when I was first figuring this stuff out a long time ago with Cert Manager, boy, this was a very complicated process. And there was a lot of config settings inside of here that it was just a total mystery. So I hope for you, it seemed a little bit more clear than it did for me. All right, my friends, in general, that's pretty much it. That is Kubernetes. We've gone through the entire process of developing and deploying an application. We then went ahead and set up this awesome workflow using Travis CI. So now at any point in time in the future, if you ever want to expand upon your cluster, I think you know what to do. If you want to create a new deployment or a new set of pods, all you got to do is make a new config file inside that K8s directory and describe what you want to deploy. That's the entire system. That's all you got to do with Kubernetes. So I hope you enjoyed this course. I hope you enjoyed Docker. I hope you enjoyed Kubernetes. If you really like the course, I do have a ton of other courses on Udemy. You can check out the next section, and I got a couple coupons in there for you to go and check out some other courses that I have on the platform. So certainly feel free to do so if you want to. All right, I hope you enjoyed the course, and I hope to see you again in the future. All right, my friends, we've now got our application up and running with Kubernetes, but there's one last thing I want to show you. Right now, we don't really have a good setup for running our code locally and doing local development with Kubernetes. Sure, we can deploy to our Minikube cluster, but going through the process of actually developing our application is a little bit awkward. Let me show you what I mean. If you recall back on the Docker Compose stuff we did, we had set up a client container for our React project. When we made use of Docker Compose, we set up a volume that mapped our local React project directory into that volume. So essentially, we were sharing our source code between our local file system and that client container. That meant that anytime we changed our code on our local machine, it updated the code inside the container as well, and the React application automatically updated right before our eyes. Now, this system only works with Docker Compose right now. We don't really have anything equivalent for Kubernetes. So right now, if you and I wanted to make some change to our local React project during development, we don't have any easy way to somehow inject that source code into our client pod. Instead, we would have to completely rebuild the client image and then rerun that kubectl apply command. That's definitely a pain. So let me show you a better way to handle this development process. We're going to be making use of a tool called Scaffold. This is a command line tool separate from Kubernetes, but designed to be used with Kubernetes just to facilitate local development. Here's how Scaffold works. Scaffold is going to watch our local React project directory for changes. So you and I might then open up our code editor and change some React component or whatever else. Once we save that file, Scaffold is going to see that a change occurred, and then Scaffold is going to jump into action. Scaffold is all about somehow taking that change in our code and getting it reflected inside of our Kubernetes cluster. It can do that with one of two different modes, and we're going to explore both these different modes. The first way that Scaffold is going to somehow update our client pod inside of our cluster is just automatically rebuild the entire client image from scratch. When I say from scratch, I don't mean like rerun every single step, including installing dependencies. It will be just a normal Docker build process. Scaffold is going to tell Docker to rebuild the client. Docker is going to see that the only change we made was to our source code, and so it's essentially just going to stick that source code into a new updated image. Scaffold will then take that image and update our local Kubernetes cluster, and then we should see our updated application appear. Now that process is still a little bit slow because we have to go through that entire sequence of rebuilding the image, even though it's kind of just the last step we are changing. And then we still have to go through that redeployment process. So the other way that Scaffold can work is mode 2, which is to essentially take the updated files or the changes we made in our local React project directory and just kind of magically inject them into our client pod. It will then be up to our client pod to somehow automatically update itself. So with mode 2 right here, if we want to go with mode 2, we need to make sure that our client pod is running in such a mode where it's going to see these updated files and automatically update itself. We've already set up Create React App. Remember, Create React App is going to automatically refresh the page anytime we change a file. We also set up our Node project as well, the backend API server, with NodeMon. So NodeMon watches for changes inside of our project directory. So right now, our API server and the client pod will automatically refresh given this updated source code. So we currently have a project that's kind of well suited for mode number 2. Okay, so now that we've got an overview of what Scaffold does, let's start to go through the installation process in the next video. In this video, we're going to install Scaffold onto our local machine. Now, the installation of Scaffold is going to be very different depending upon the operating system you are running. You can find installation directions at this link right here, so scaffold.dev and so on. I'm going to open up a new browser tab and navigate to that page. All right, so here's the Scaffold documentation for the Getting Started page right here. You can essentially ignore everything up at the top. We're really just going to go straight down to installing Scaffold right here. So you'll see that there are installation directions for Linux, Mac, and Windows. Installation on Linux and Mac are going to be pretty straightforward. So on Linux, just run those commands. That's pretty much it. On Mac OS, you can install Scaffold with Homebrew. I'm going to assume that if you've made it this far inside this course, you probably already have Homebrew installed. If you don't, and you try to run that command and see an error around don't know what brew is, then just make sure you go in and install Homebrew very quickly. Unfortunately, installation on Windows is a little bit more complicated. So this installation right here with Chocolatey, this is assuming that you have Chocolatey installed. That is a Python package manager for Windows. It's extremely possible that you might not have Chocolatey installed on a Windows machine unless you are 100% sure that you have gone through that installation process previously. So if you do not have Chocolatey installed, I recommend going with these other options, which is to download the binary and then add it to your path. To add something to a path on Windows, just do a quick Google search. It'll tell you exactly how to do this. Okay, so I'm using Mac OS, so I'm going to run that command right there, brew install scaffold. Over at my terminal, I'll do a brew install scaffold like so, and that's pretty much it. Now, I already have Scaffold installed on my local machine, so I'm just going to see something that says, hey, you've already got this. All right, so once you get Scaffold up and running, we'll take a quick pause, come back in the next video, and start making use of it inside of our project. Hopefully, you've now got Scaffold installed on your local system. To make sure that everything is working correctly, you should be able to run scaffold version at the terminal and see a version print up like so. If you are running a version newer than me, that's totally fine. Scaffold has remained relatively unchanged over a pretty good amount of time, and to be honest, right before I recorded this video, I was actually running version 0.2.2, and I went through the process that we're about to go through for our application, and everything still worked fine. So it's a relatively stable API. All right, so now that we've got Scaffold up and running, we're going to provide some configuration to Scaffold so that it knows how to handle our project. As you might guess, this is going to take the form of creating a YAML file. So here's my complex application open inside of my code editor. Inside of my root project directory, I'm going to create a very special file to configure how Scaffold works. So inside of my root project, I will create a file called scaffold.yaml, like so. So we're going to put together a YAML file very similar to many other that we've put together inside this course. This file in general is going to look a lot like a Docker Compose file, but with a couple extra settings here and there. I'm going to tell you about all the different important settings you need to be aware of, but if you want to, you can always go back over to the Scaffold page, check out concepts, tutorials, and references. And if you look at references in particular, there's a section on scaffold.yaml, and it's essentially an annotated YAML file that will appear, and it will tell you about the meaning of all the different options we can set. It looks like my browser is having a little bit of trouble actually. Oh, okay, there it is finally. Just going a little bit slow here. Eventually, I will see a big list of all the different, there we go, finally. So here's all the different configuration options we can provide, but I'm going to tell you all the different options you need to be aware of. All right, so back inside my code editor, we're going to first start off with a little bit of boilerplate. So I'll say API version scaffold/v1 beta 2, like so. Notice the capital V on here. As usual, inside of our YAML file, if you make any typo inside of here, stuff is not going to work as expected. Next up, we're going to specify a kind of config with a capital C like so. And then here's where things finally get interesting. We're going to specify a section called build. So inside of build, we're going to essentially list out all the different images or different deployments that we want Scaffold to manage. Inside the build section, the first option we're going to specify is something called local. And then inside there, we'll do a push of false. So by default, Scaffold, whenever it builds an image, is going to try to push the built image off to, say, Docker Hub or whatever your default Docker repository is. For local development, it's extremely likely that you probably don't want to push these images off to some hub or repository. You probably just want to make a change on your local machine and test it out yourself. So you're almost always, in my opinion, you might have a very different workflow. You're very likely going to have local push false, which just means every time that Scaffold builds an image, we're not going to do that push. All right, so next up, we're going to define a new image or a new container that we want Scaffold to manage. Scaffold refers to these as artifacts. So we'll define artifacts like so. And this is going to be an array of different images, or essentially containers, we want Scaffold to manage. So I'm going to put in that little dash right there. Remember, in YAML, that indicates an array. I'll then provide the name of the first image that I want Scaffold to manage. So for me, it's going to be Stephen Greider / multi-client like so. After that, we're going to specify the folder where we are building this image from. So for you and me, it's going to be the client directory. So I will say context is client. Remember, context in the world of Docker usually refers to a folder or something like that. After that, we are going to tell Scaffold exactly what Docker file we want it to use when building our client image. So for you and me, it's going to be that dockerfile.dev file right here. Remember, that is the Docker file we use when we're trying to run our React application in a development mode. So I will say dockerfile.dev. Okay? And then finally, this is the really meaningful option. Remember, I just told you that Scaffold operates in two separate modes. It has mode 1, where anytime it detects a change, it's going to attempt to rebuild the entire image from scratch. And with mode 2, it's going to just try to take updated files and eject them into the client pod. So in the case of our multi-client application, we want to use mode number 2, because our client pod, our React application, is set up to automatically see changes to files and update itself. So in order to tell Scaffold to use mode number 2, we're going to set another property here called sync. Sync is going to be a listing right here, so a couple of key value pairs. We're going to provide file paths right here that can be kind of glob matchers, and this is going to tell what files we want Scaffold to use when attempting to use mode number 2. So in our case, we're going to put in here **/star.js like so. So this right here essentially means anytime Scaffold sees a JavaScript file change, just take that JavaScript file and throw it into the container. We're going to do that same thing for CSS and HTML files as well. So once again, this section right here is essentially what enables mode 2 of Scaffold. Anytime it sees a change to a JavaScript file, a CSS file, or an HTML file, take that updated file and just inject it into our running pod, or container in this case. Okay, so that's kind of part 1 of our scaffold.yaml file. Right now, we are telling Scaffold only to manage our multi-client image, but eventually we will also add in some instructions on how Scaffold should manage, say, our API server and the worker as well. All right, so I'm going to save this file right here. We're going to take a quick pause. And when we come back, we're going to finish off a little bit more config inside this file. In the last video, we started working on our Scaffold config file. So we've added in an artifact here. Remember, that is telling Scaffold that we want it to manage our client project. All right, so now the next thing we're going to do is go down to the very base layer of indentation here. So notice how I'm all the way back out. We're going to set up a section called deploy. We're going to pass in a couple nested properties here. So we're going to say deploy, kubectl, manifests, and then we're going to list out all the different config files that we want Scaffold to manage for us. When I say config files, I'm talking about Kubernetes YAML files. So essentially in this case, we're going to attempt to tell Scaffold that we wanted to manage our multi-client deployment using the client-deployment YAML file. So as an array entry right here, I'll say k8/client-deployment.yaml. All right, and that's pretty much it. So now anytime we start up Scaffold, it's going to attempt to apply that config file to our Kubernetes cluster. Scaffold simultaneously is going to start watching our client project directory for changes. If we make any changes to a JavaScript file, CSS, or HTML, it's going to inject those changed files into our multi-client pod or container. One quick thing I want to mention is that if we make any changes to a file besides a JavaScript, CSS, or HTML file, then Scaffold is going to fall back to mode 1. So if we change anything besides CSS, HTML, or JavaScript, it's going to fall back to just rebuilding that client image from scratch and using it to update our Kubernetes cluster. Okay, so that's it for our config for just the client deployment. So I'm now going to save this file, then we will do a quick test. So I'm going to flip back over to my terminal. Inside of my complex project directory, I'm going to start up Scaffold by running scaffold dev, like so. All right, there we go. So you're going to see that Scaffold's going to immediately try to build our client image. It's then going to take that built image and throw it into our Kubernetes cluster. So you can see that it created that client deployment right here. We'll then start to see some logs coming out of that client image that Scaffold is now, or excuse me, client container that Scaffold is now managing. Let me zoom out here just so we can see those logs more easily. And so we can see the message that the React application has started up successfully in development mode. We're seeing all this output 3 times because remember, our deployment file specifies that we should run 3 instances of the client pod. So now we can flip back over to our browser and test this out. I'm going to go to k8smulti.com. Remember, that is the host alias I set up on my local machine, and I'll see the app appear. Now, we already really had our application appearing, so what's different here? Well, remember, anytime we now change a project file, we should automatically see our React application get the update. So to test that out, I'll go back over to my code editor. In my client directory, I'll find the src folder, and then inside there, I'll find the app.js file. Remember, inside of here is that h1 tag that has that big header at the top. So I'll just make some change to that text. I'll say like updated. So fib calculator updated. So I can now save this file. As soon as I do, I'm going to change back over to my terminal, and we're going to see how Scaffold responds to that. So right here, it says syncing one file for Stephen Grider multi-client. So Scaffold has seen that I changed the JavaScript file. It's going to take that file and try to inject it into that multi-client image container. And we can then see some update messages right here from those 3 separate pods that are running multi-client, telling us, hey, all right, we got that update successfully. The compiled successfully message is coming from create React app. So this is essentially create React app saying, hey, we see a change to a file. We're going to try to rebuild our client project. When I say client project, I'm talking about like our client JavaScript code, not rebuilding an image or anything like that. So if I now flip back over to my browser, I'll see updated appear. If you do not see the live update right here, it's totally fine. I have noticed that Scaffold with injecting stuff is sometimes a little bit finicky. You will just about always see the files injected into the container. Maybe it's not Scaffold that's finicky, but rather Create React App is. So sometimes Create React App will not automatically update the page. If it doesn't, just do a manual refresh, and you should then see the update appear. Okay, so clearly we made a change, and we did not have to rebuild an image manually or anything like that. We just saw the change appear. So as you might guess, this is an amazing tool for local development with Kubernetes. And there's still a couple more things I want to tell you about Scaffold, so let's take a quick pause right here and continue in the next video. In this video, there's a couple odds and ends I want to mention around Scaffold. So you'll notice that down here at the very bottom of the config file, we added in this manifest section, and we provided a path to just that client deployment YAML file. So by adding in this YAML file right here, anytime we start up Scaffold with scaffold dev at our terminal, Scaffold will automatically try to apply that YAML config file to our Kubernetes cluster. Now here's the important part. Anytime we close down Scaffold, Scaffold will immediately try to delete the deployment that we created with that file as well. So take a look at this. If I flip back over to my browser, my terminal, and I hit Control-C, we're going to automatically see deployment apps client deployment deleted right here. If I now attempt to get my pods, I'll see that all of my client pods have been deleted automatically. So this is another feature of Scaffold that's really nice. Right now, anytime you do some local Kubernetes development, if you decide to like pause working on one project and start working on another, you might have a ton of different containers or pods in the same namespace, and it's kind of hard to tell which is which. So by using Scaffold, you can automatically start up one set of different pods and then automatically close them all down as soon as you stop Scaffold as well. At present, we are not having our server deployment being managed or our worker deployment being managed by Scaffold. So if we wanted to make sure that those pods also started up and got shut down automatically, we could add them to that manifest section. Let's do that right now. So back over here, I can add in K8s. And we're going to go for our server deployment. And we can also do our K8s worker deployment as well. We are not limited just to having deployments being managed by Scaffold. We can also add in services as well. So if we wanted to make sure that we also say shut down the server cluster IP service, we can just add that as an additional entry. So I can do server cluster IP service.yaml like so. And the same thing for, let's just go ahead and be complete here. I'll add in also my client cluster IP service, and the worker, our worker doesn't have one. So we'll just do server and client. All right, so I can now save this file, flip back over to my terminal. I can start everything up with a scaffold dev. So we'll see that Scaffold has automatically applied all those different config files. Our React application is going to start up. And then at any point in time, we can hit Control-C, and we'll see that Scaffold's going to shut down all of our client pods, all the server pods, and the worker pod as well. So I'll do that right now. I'll hit Control-C. That's going to delete all those pods. And now if I get my pods, yep, I will see that the server deployment, while it's still listed, it is being terminated along with the worker as well. So if I run that again right now, yeah, there we go. Now the server and the workers are completely gone. And there is kind of one downside to this entire approach of adding in all these different services or manifests into this scaffold file right here. Because remember, we're now saying that as soon as we close down Scaffold, we're going to essentially delete all the things we have listed here. So the downside to that is that if you have anything persistent, like maybe a database or a volume that you want to keep around for development purposes, because maybe you've got a lot of test data loaded on there or something like that, do not add those things into your Scaffold file. Because if you have any persistent data in the form of volumes or pods or whatever else, Scaffold is going to delete that stuff as soon as you close it down. So I would recommend not adding those things to your Scaffold file. And you can actually see in my environment right here, I actually have a Postgres deployment that's been running for 110 days. So that's for a very different project that I've been working on for quite a while. I don't want that deployment for Postgres to be managed by Scaffold because I have some persistent test data in there, and I don't want to have to be recreating that database and reseeding that database with all that test data every single time I decide to go back and start using Scaffold on it again. So in the case of all of your different pods for running React applications or APIs or kind of these stateless services, no problem adding them to the Scaffold file. But for anything related to data, you might not want to add it in because, like I said, Scaffold is just going to very quickly delete it. All right, so now that we understand a lot more about Scaffold, I want to add in all of our different services or deployments to this thing so that we can get some live updates on our server and our worker and all that good stuff as well. So let's take a quick pause. When we come back, we'll just add in some more configuration for artifacts for both the worker and the server. So I'll see you in just a minute. In this video, we're going to add in some artifact sections for our worker and our server so that we can get some automatic code reload with those two things as well. So inside of my Scaffold dev file, I'm going to find my artifact section and I'll add in another array entry. As usual, please make sure that you've got that dash on the same tab line as the one right above it. If you indent that thing, you're going to very quickly see an error message. All right, so we'll add in an artifact section for how about our server first. So I'll first specify my image, which is going to have a name for me of Stephen Greider multi-server, I think is what we called it. I'm just going to do a quick check here. Here's my server deployment, called it multi-server. Okay, very good. I'll then specify the context, which is essentially just the directory for that. So in this case, server. I'll then specify the Docker file that I want to use, which is going to be dockerfile.dev. And then we can list out all the different things that we want to have synced. So in this case, we're not going to have any CSS or HTML files. We really just have JavaScript files inside of our server. So I'll do ****JS:* like so. Now we can repeat that same process for worker as well. So I'll once again add in a dash, image of Stephen Greider multi-worker. The context is the worker directory. For Docker, we want to tell it to use the Docker file of dockerfile.dev. And once again, we only really want to sync ****JS like so. Now I want to repeat one more time because this is a little tricky thing.
The only time that you're going to want this to use this mode 2 method of syncing files is when your different subprojects have some ability to detect changes and automatically reload themselves. So we built that into our server and our worker projects as well. Remember, the Docker file dev for each of those starts up those projects using the dev script. And that dev script runs nodemon, which watches for changes in the local project directory, in this case inside the container, and automatically restarts the project. So if our subprojects here of server and worker do not make use of newly synced files coming in from Scaffold, then it's pointless to try to use Scaffold to sync those files. Instead, if we don't have that ability, we would want Scaffold to operate in mode 1, which is to say, automatically rebuild the entire image anytime we make a change. All right, so now that we've added those in, let's do a quick test. So I'm going to flip back over to my terminal. I'll do a scaffold dev once again. And now we're going to see that we are building those 3 separate images. Those things all got deployed. We'll see some startup information here really quickly. There's the server running nodemon. We probably can also see the worker inside of here as well. It looks like my server has an error around connecting to Postgres. That's totally fine, kind of outside the realm of what we're doing right now. And eventually it looks like everything is started up. So I'm going to very quickly test this inside of my browser. I'll do a refresh here, and yep, still got this running. So now let's try making a change to our server project and just make sure that the files get synced and that the server automatically restarts. So for that, I'll find my server index.js file. And to test out a change, maybe let's try to hard code some value that we're sending back. So right now, notice how values all. Remember, we're trying to get that information coming from Postgres. So rather than sending back some information coming from Postgres, I'm going to instead comment out the values line and then send back some hard-coded values. So I'll just say, always send 1, 2, 3 like so. Again, I'm just doing this to have some change that we can actually detect inside of our application. So I'll now save this file. If I flip back over to my terminal, I'll see that Scaffold has seen that we made a change and synced that file. And then we can see that nodemon inside of our server pods has automatically restarted. So now we can flip back over to our browser, do a refresh, and I'll see, okay, I probably put in the incorrect format of data. I think that's probably supposed to be an array of arrays. So my mistake there. However, if we open up our network request log and we look at all, we will see that we did receive an array of 1, 2, 3. So we definitely successfully saw that change sync to our server, and the server automatically restarted. All right, so now last thing we can do once we're all done with development, we can stop Scaffold by hitting Control-C. And all those different deployments and services, everything automatically get cleaned up after us. All right, so that's it. That's pretty much Scaffold in a nutshell. Personally, I use Scaffold on every Kubernetes project I work on because it makes it incredibly simple to, first off, work on different projects on your local machine. And it also makes it really easy and straightforward to do local development environments. So like work on a React application or an API without having to constantly rebuild all these images and manually redeploy them every time as well. All right, so I hope you enjoyed this, and we'll take a pause right here, and that's pretty much it for now. So I'll catch you later.